Check, check, check. Oh, yeah. Okay. Can you guys hear me now? Is everything okay? How are we doing today? Please tell me somebody can hear me. I don't want to
Rusty
be.
Ross is the best. The best a man can get.
PC double D.
Who is the best? Rusty Russ is the
Holy
best.
hell. Okay. What's up, guys? How's it going? Hello, hello. What do we got? Who do we got? We got. Who was first? Chill and Relax was first. Sloth Tech, TFN, MDL, LDT, 3D Medic, Ali U, JFix, PC Double D, Manga. Hell yeah. What's up, guys? Where do we leave off last? We left off in a bad state. PS4, PSU. I'm not too confident about this one, guys. I have been trying to do some research and homework. I say research, YouTube. But we're in for it today. It's 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 above my pay grade, that's for sure. But we're gonna try to power through this. I did try to buy some stuff, and hopefully this stuff will help us better diagnose. We'll say diagnose. A PS will be a challenge. Yeah. What's up, Forgot? So let me show you what I got. Here we go. Oh, what's this? Oh, where's Sloth? Is Sloth in here? No, he's. Oh, there he is. What's up, Sloth? What's this? Oh, it's a koozie. How about we do this first, huh? Look at that perfect fit. Oh God, it's beautiful. Beautiful. Red Bull to keep me going. Ooh, I gotta shake it out, guys. This is gonna be a fun one. Do you have something to discharge the caps? Yeah, I got this. This super amazing, super safe um, cap discharger. Which reminds me, I should probably say a few words here. Okay, 1 second. Here we go. I'm a hobbyist in my garage. What you see today should not be replicated. Please, for the love of all your safety, do not do what I'm about to do today. I am learning. I have no knowledge about this stuff. You're gonna see today how limited my knowledge is. I have been trying to understand a lot of these components that you're gonna see today, but still, to the very, very utmost, like I can't mention it enough, do not do what I'm about to do today. I do not know how to handle power supplies. This is gonna be very dangerous. I might even get shocked today, but we're gonna dive in and try to diagnose a PS4 power supply. With that being said, one other thing. Today is stream 4 of 4 for the Dan Nations. I'm taking that from Roy. Any and all donations through the PayPal link will be directly going to Dan and his mother-in-law for medical expenses towards her cancer treatment. I know you guys have been hearing me harp on this enough, so I'm just going to kind of keep moving along. But yes, any and all donations today through the PayPal link will be going to Dan and his family to help support medical finances. Okay, back at it. Here we go. Are you comfortable in trusting that discharger? No. To be honest with you, no. This is a cheap one, the cheapest one, along with everything else that I have on this bench. Everything is super cheap here, guys. I did buy some sort of a component tester. I bought this brand new, but it came open in the box, so it is already used. That's going to be fun to try to figure out. I also have a variable variac thing that I've had on the back shelf for a long time. This has been used for like generator fault finding and testing and stuff like that. Not necessarily what we're going to be using it for today, but it's going to come in handy because I have been watching a couple. What was that? Error. You need to change the video resolution. Current resolution 1440p, which is not supported in the configuration. What? Am I lagging? Oh, hell no. Am I lagging? Oh, hell nah. 2 seconds. Um, well, that sucks. Mm, hold on. Let me read, let me read. Bzz, yeah, yes, danger high voltage. The best a man can get. Tongue works
Rusty
too.
Russ
Disclaimer.
is the best.
Who is the best?
Thank you
Rusty
guys.
Russ
Thank
is
you
the
guys.
best.
Yeah, we'll see. We'll see how it goes. I'm gonna do it just like Russ. No PC double D. Follow along with home tutorial, please, guys. Please don't. If it is wrong, then you will need to wait. You will not need any product for your hair. Thank you. Thank you for God. I appreciate that. Just show us you're replacing a bunch of parts, then swap it out to a new one and say it's fixed. I mean, I do have a couple of other chips here. Okay, thank you. What's up, Chris? No lag on Twitch. That's due to fast chat setting. Oh, I did put it on ultra low latency instead of normally low latency. Thank you, PC Double D. Stream seems fine. Thank you, MDL. What is black? Smoking and sitting in a chair. Whoa, easy there. Easy there, TFN. Ultra is 1080p, yeah. So 1080p, because I made Twitch my default, I don't have like affiliate with Twitch yet. So I'm only streaming in 1080p, and I thought YouTube was 1080p as well. So that's why I put ultra low latency. Jason, I'm not going to answer that question. What's up, Sean? Okay. Here we go, guys. Here we go. Let me try to explain to you guys, the best of my knowledge, my very simplified, extremely crude, garage-taught knowledge. This is a PSU, yeah? This is this is a working PSU. This is a bad PSU. See that? I got a little X right there. Right there. That means this is the bad one, okay? We're going to keep that in mind as we move along. So I have a working PSU, same model, same everything, so we can test components alongside. I also have a schematic. Now, I was actually really embarrassed trying to read this schematic last time because I don't know schematics. There's a lot of stuff, a lot of values, all very useful. We're going to be referring to this quite a bit, okay? Oh, God. Give me 2 seconds here, guys. Okay. Just charge them. Yeah, they're not charged up. They're fine. See, no red light. No. We're a-okay. Oh, Sean, what's up, Sean? Man, this brings me back to a few decades.
Lego test?
Carthor, what's up? Dan, hello. Pico, hello guys, hello. I really appreciate you guys for hanging out and showing up. This is gonna be BrizTech, Joe, GT Auto. Oh my gosh, you guys, Joseph, Andy Raid. Oh, is that what happened? You guys are all showing up in force. This is gonna be this is gonna be terrible, guys. Let's learn about PSUs. Yeah, let's all learn together, Mookie. Hallie, you raid. Thank you for the raid, Andy. I appreciate that, sir. SER. It's Andy's fault. No. So I bought. Actually really surprised that these showed up. I bought these a week ago, the last time we were streaming, and it's the DDA001AG chip and the DNP012A chip, which is in charge of like 12 volt regulation and power factor correction. You hear that, Sloth? Power factor correction. Well, what is power factor correction, you might be asking? I'm going to try to explain it in the most crude of terms, okay, guys? So before we get started, PS4, PSU. We have 120, if you're in the US, coming in right here. Bypasses through this fuse, goes through this little device, goes through these coils, and then enters this bridge rectifier right here. Now this bridge rectifier is going to turn AC into DC and put it through this coil right here. This is not necessarily an inductor, but it's more of a coil. It's going to jump it up to a certain amount of voltage, and then it's going to send it through to these caps right here. These caps are going to store a lot of electricity, 450 volts potentially, and it's going to be channeled through a couple of these MOSFETs. I'm not exactly sure which one it is. We're going to have to look at the schematics. And then while it's doing all of that, this is also going to go into this coil right here, which is our 5-volt standby, which comes out of here. And then we're also going to have a 12-volt standby, which comes out of here. With all that being said, I want to show you guys what I've tried to oh my gosh, you guys are crazy. Hold on, I got to read chat. I've tried to test some components offline during the week, and I've tried to troubleshoot and diagnose and all this and that. I have not been able to fault find any of these issues on the back of the board, any of these chips.
Russ is the best.
Thank you, Andy. So this is going to be, I have an idea about what the issue is, but it's going to be, it's not going to be a 5-minute fix. It's going to be a drawn out long process of me going back from component testing to the schematics, which are here. All this stuff. Look at all fun all this stuff is, right? Oh my gosh, slow down. Hold on, here we go, hold on. In case you guys missed it, don't do what I'm about to do. Full disclaimer, I'm not a professional. I'm a guy in his garage. Please don't do what I'm about to do, okay, guys? 666 subs, yep. I'm the devil. We used an oscilloscope for component back in the days. That's the one thing I don't have yet, forgot, is the oscilloscope. I just bought this cheap ass tester for testing components. I don't even think this is good, to be honest with you guys. I can't even vouch for it. But it was cheap. I bought it for like 20 bucks on Amazon, so we're not gonna like heavily rely on that. British invasion. I've never seen anyone get electrocuted live. Well, there's always that possibility. What's up, Ricochet? Taking over. All your bases are ours. Pico, Tiger's Raid. Triple R dies today. Nah, I gotta. We'll just. It'll be fine. It'll be fine. The 666 subs. That's why, huh? Someone sub now. No, it's fine. It's good. That's a good number. It's a good number to test PSUs on. What's up, Rick? What's up, Andy? Wow, Jason. 240 for me. What's up, Joseph? ET. Catching up. Blah, blah, blah. Blur cam. Okay, focus. And focus. No focus. Focus. And then focus. Hopefully that's better. Slapstick, hello? You're interested in an open source DIY lab PSU project maybe. Built from on top of an open DPS based on ESP home. With a neat 7/1 display.
At JFix1 became a member. At JFix1 celebrates 1 month of membership.
JFix! No shot. JFix, I think you're the first one. Oh, no, Michael DeLima. You guys both got it. The bronze are celebrating 2 months. Hell yeah. Okay. Sorry, Slapstick. I have no idea what you're talking about. Shiny Red, Variac. Yep. Guys, I can't go. Come on, come on, come on, come on, come on, come on. What's up, Glisha? Troubleshooting without knowing how to read schematics on my J. Yeah, yep. Forgot. That's what we're doing today. Fine, no shocks. I don't have a PS4, PSU, so I can't copy. Good. We have faith. Thank you. Double D. Just don't hurt yourself. No, it's fine, guys. It's fine. It's fine. It's fine. It's fine. Was it something I said? Yes, Jason. Yes. The backdoor comment. Want to be ninja. Okay. Are we good? Bronze. Jason, man, you are wild today. Okay. Okay.
At Joseph underscore Neil underscore the underscore Lilliput became a member.
The camera's out. Let me square that up a bit. What is going on?
Ricochet 2025.
What's going on, you guys? You guys. Okay, I haven't even started yet.
I
haven't even started yet, guys. Holy moly. Thank you for the gifted memberships. Okay. I'm going to try to post this together. Here we go.
At Aussie57 became a member.
Okay. Sean Causeway gifted a membership. Joseph Neal. Also to Ozzy. Also to Ricochet.
At Indy5280 became a member.
Okay. GT Auto gifting memberships to Indy. Peter Dunlop.
Peter
What?
Dunlop 8801
Peter, you got a
member.
membership. That's what's up. And Michusana. Much appreciated, guys.
At DJ Juno became a member.
Why didn't that one print out? Hold on. Hold on. What's going on?
At Mitch Sona became a member.
Wait a minute. You guys broke my system? Sean gifted 5 memberships. GT Auto also
At
gifted 5.
Farmer 813 became a member.
Why do I only have 3 printouts for each of you guys? Who am I missing? Robcat. We didn't see Robcat. Some receipts are still loading. What is that about? Indy Peter. DJ Juno, we didn't see. Lead Farmer. You guys broke my streamer bot. You guys broke my printer bot. Thank you for that. Okay. Let me give a box of stuff. Get you guys put in there. Oh, Lord. Okay. Slapstick. It's not hard. I built a DIY lab PSU for $200. That can compete easily with $600 devices. Maybe that's easier. Okay. All right. Okay. That makes more sense. But does your PSU have on-screen display? Does your PSU have on-board display? Like right here. Can we see it on OBS? Is that a thing? You have a printer that prints it out? Yeah, I do, Carthor. Yep. But it's, you guys jammed it up by gifting all at once. Okay. All right. Okay. Under a rock. What does that mean? What did Sloth say? Guys. I'm not even started yet. I thought Clunge was the one obsessed with printers. Yeah. Hurry up and get shocked so we can laugh. Okay. Oh, fuck. Let's start nice and easy, guys. Whoever gifted me an R, thank you. No problem, guys. Let's start off nice and easy. This is our problem one. This is our good one. There's no X on the back of this one, so that's our good one. We're going to start off nice and easy because where we left off, I was lost, okay? We're going to see here at our meter, okay? We're going to go into continuity mode, which is there. Please work. For the love of baby Jesus, please work. Cool. Continuity mode. No 1440p. No. I made Twitch my primary, so Twitch doesn't allow me to stream in 1440p because I'm not an affiliate. So 1080p is all we get. MX Power. It's always the same people here. Why don't they speak fluent English? I have to watch videos twice. First of all, welcome MX Power. Good to see you. Nice to see you. What's up, Ozzy? Also, sorry I missed you. Poor Max Power, learn English. Okay. Okay. Okay, god damn it, guys. Where do we start when we start with the PSU? Well, we start where the power comes in, right? This is our power in, and it goes through the fuse. As shown, I know it's here. I know it's here. Right here. Well, wrong one. Here. At this little segment right here. This is our power coming in, our line and our neutral. We're going to have our F1 fuse showing up right here. We have a couple of other components. We have this guy, which I'm assuming is some kind of coil. We have another component here going through another coil, some more various components, and blah, 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 blah. You guys get it? Because I don't. But if we check this fuse, right? Son of a gun. Continuity mode. Why? Ford or fix, man. Why is your software glitching on me, buddy? Continuity. Good stuff, guys. Lean English? Don't be mean, guys. JKMP. Yeah, you guys, be chill. Do you read the contract that came with the koozie? You got to show at least 3 times per stream. So I'm not going to plug this in yet. We can actually, you know what? I probably should. So we have this section of the PSU, which is our input section. And this is our bridge rectifier, which takes our 120, converts it to DC, and puts it a certain amount of voltage into this coil. This coil bumps it up and actually stores capacity into these capacitors, right? With that being said, I want to show you guys where I'm at with this. I'm going to try to speed this along because I've been doing testing and everything like that beforehand. So I don't want to bore you guys too much, right? This is our variable AC wonderful contraption. It's cheap. It's made from China. And it's got a 5 amp fuse that we're more likely going to break. Okay, so we flip it on. Okay, now let me show you what our AC output is. 121 volts. We can crank it all the way up. 145, which is way too much. We can crank it all the way down to 70 something, whatever. But we want 120 volts, right? Roughly 121 volts. Yes? Cool. What's up, Greg? Trying with no scope. We'll get to the scope. We'll get to the scope. Thank you, Carthor. It's a cheap channel one. It's not that nice. But I appreciate the comment. Oh my God, it's on. Okay. So here's what we need to do, right? We need to make sure that we get past this first stage into our God damn it, I already forgot what it's called. It's not power factor yet. It is the power factor correction, but we're gonna make sure we have 5 volts. We're gonna make sure we have our 12 volts, because if we don't get these and we don't get the power factor correction, like that's the issue, right? So I'm gonna plug this in. Okay, we have power, right? And for the love of God, guys, please do not copy what I'm doing. Please do not copy what I'm doing. Here at this connector, we have our 5 volt standby, and we use this to trigger the power supply to come on. Okay, so if I measure, Come on. We can see 4.68 volts. So we get our 5 volt standby. If I measure here at our 12 volt standby, we get nothing yet because we haven't enabled the trigger yet. If we measure at these capacitors, I am on DC here, and let me switch the leads because it's going to be negative volts if not. If we measure here, we get 167 volts that will very much likely hurt. Okay, so we know to an extent that the coil is at least, the bridge rectifier is at least taking our 120 in, rectifying it to DC, and inputting it into this coil so we can get our 160 volts, 167 volts. Okay, so I'm going to switch this off. Okay, I'm going to discharge the caps because I don't want to die. 160 is not that bad. But once we put on this enable signal, the power factor correction should charge these guys to about 400 volts. That is what enables us to have the correct right amount of amperage to send to our 12 volts and supply the 16 amps necessary for this power supply. I might be saying all of this wrong. I could be very well saying all of this wrong, okay? So just remember, I'm not an expert. I've only had a week to study this shit, okay, guys? Why does AC and DC have the symbol? What are you talking about? What are you talking about? What are you talking about? AC and DC? I don't know. Talk to Fortifix about it. It's the same. It is the same symbol, huh? Oh, that's hilarious. That is hilarious. Fortifix, we've all discovered that your meter shows AC and DC voltage the same. That's hilarious. Cool. Okay. Where are we at? Rectified, yes. Looks it looks nicer than my Variax. Come on, guys. Come on. Be aware that Variac is not ISO rated. Have that one too. What does that even mean, ISO? At least wear gloves? Nah, it's fine. We're fine. Doing great with the explanations. Thank you, Sloth. I appreciate that, but I'm probably not. We found a bug. Who is Russ imitating? Sounds different. I don't know what that means. Okay. So, we have here a wonderful, amazing, beautiful, single pole, single throw switch. And what's the point of this switch, you guys might be asking? This switch is actually going to act as our 5 volt standby enable pin. Now you can do this by shorting out the pins yourself with a pair of tweezers, just jumping 5 VSB and AC DC standby. Zoom in just a bit. The very most outer pins right here. Now you can just short those out and you can be good. But I am cautioning on the side of error today, and I am gonna solder this switch to these connection points right here, because it's gonna be much easier than using the tweezers. This is just a regular old switch, guys. Oh, Lord. Oh, Lord. Here we go. I know you can't see. I know you can't see, but just trust me. Actually, you know what? Let's just do it. Let's just do it. You guys can see what I'm doing. It's a lot easier. Makes a whole lot more sense. Pin 1 and pin 5 is what correlates. Yeah, I'm going to get shocked. To our ACD standby and our 5 VSB right there. Okay? The outermost pins. Just going to add. Cool. This is going to look terrible. I know it's going to look terrible. Let me trim some of these leads down just a bit here.
Wiggle test.
No wiggles yet, guys. Okay, let's take a beat. Let's take a breath. Let's try to slow down enough to where I'm not going to kill myself, okay? This looks terrible. This looks horrible. Good enough. Here we go. Oh crap. These pads right here. Oh crap. Crappity crap crap. Hold on. Nope, I don't like it. I don't know what those pads are. Are those ground? Those might be ground. Nope. Nope. This is bad. I don't like the way this is lining up. I don't like this at all. What's up, NanoFix? Variac not isolated from mains. No, it's probably not. So if I lose power, you guys know why. He's being West Coast Russ Bro. This is Mr. Russ, the substitute teacher today to educate the online class. He even has sleeves on, unlike Triple R with his vest top. Do not do what I'm doing, guys. For the love of all things, do not do what you guys see here today. Please, I am not an expert. Do you have a spare connector you could use for the switch? I do. I didn't want to cut it, but I can. Looks like a ground, yeah. Cut the wire shorter. Yeah, we could do that. Never do what Russ does. Yep, please, do not do what you guys see today. I cannot stress that enough. Do not do what you guys see here today. I am still learning. I am still trying to learn. And I'm self-taught. I went to the University of YouTube. It's not a real education, okay? And I've only had a week to do this.
Who is the best? Rusty Russ is the best.
No, it's not true. It's not true.
Who is the best? Rusty Russ is the best.
Let me tin the wire. Hold on. That actually looks like it's clear. That looks like it's not touching anything. Oh gosh, you guys are making me so nervous right now.
And we have picture. I can't believe.
You guys are
Rusty
funny.
Russ Repairs is the best.
You guys are funny. So funny.
Rusty Russ is the best.
I don't have any depth of field. Come on. Oh God, is this gonna work? That should be fine. That should be fine. Oh God. So, what are we gonna do now? Now, we need to make sure, since we already seen that we had our 5-volt standby, we need to make sure that we have our 12-volt standby. It may or may not populate. So what do we have here? This is a secondary meter. We're going to go into DC mode, and we're going to plop this terminal here. We're going to plop this terminal here. Positive, negative. Okay, guys? All right. Our variable AC is off, so I should be safe to plug this in. Okay. Yes, it's going to happen. I know it's going to happen. Is this better with the light? Without the light? It's probably better without the light. So I'm going to turn this on. I don't know if this switch is on or not yet. So if it's on, we're going to look for our 12 volts here. If it's off, I'll press the button and we're going to look for our 12 volts here. You guys, I'm not even keeping up with the chat. Hold on, hold on, hold on. But mommy, Triple R showed me how to do it. No, TFN. Okay. 3D Medic, cut wire shorter. Yep. Cue the jackass theme. What's up, 8-bit? I beg to differ. YouTube is better education than school. I agree to some extent. You just have to watch the right YouTube. Okay. Are we good? Can't believe. Soren. Yep. Death switch. 3, 2, 1. Boom. Okay. Stick it on using one hand. Bye, Russ. Thank you, GTO. Final words. Here we go. Just realized I should not stream myself working on a PSU. Yes, for the love of everything, Sloth Tech, do some research, more than a week long. Okay, so I'm gonna turn this on. We're gonna see if the switch is actually on or not, because I don't know if it's on or not. I could check continuity, but it's more fun this way. Pay attention to here. We know we get our 5-volt. We're gonna see if we get our 12-volt here, okay? Here we go. Okay, 11-volt, right? And dropping. Cool? All right, so we know the switch was on. Turn that off. We know it's in the off position. So we get our 12 volts for a brief second, right? Can we all agree that we've seen 11 volts? If not, let me turn this off. We'll turn this back on, and we'll do it again. We'll do it one more time. Okay? 11.7. I seen an 11.7, close enough to 12 volts. So what that tells me is that these components here are acting okay. We get our 5-volt, we get our 12-volt. What our issue is, actually, let me pause. Let me just pause. Let me take a breath. Let me show you guys what else I found during the course of this week. I bought some new probe leads. Yeah? You guys have probably seen them here. Yeah? They plug in here. Yeah? I have to keep in mind that when I use these, I have them like they're... Oh God, don't spill that Red Bull. Oh God. I have them like plugged in with a banana jack that's plugged into another banana jack, okay? So when I turn this on, the tips of my probes are also going to be holding whatever voltage these caps are going to be storing. So I'm going to put one here, and I'm going to put one on the opposite side of my stream deck so that there's no way for the streams to cross. And I cannot tell you guys this enough. Sloth Tech, thank you for the Red Bull. Koozie. Do not do what I'm doing. Please. Lots of bananas, yes. Negative side of the capacitor, right meow. Positive side of the capacitor, right meow. Flip that over to here. The meter itself is going to show our DC voltage. Fortifix, come on, buddy. Come on. Come on. Why is it OL? There, yeah, that's live. Why is it OL? Fortifix, man. Okay. We can see 3 volts and climbing because when you discharge a cap, it does creep up because of the contents of the caps. They self-charge themselves, okay? Oh, power supplies are fun. What's up, Wicked? Sponsorship has been fulfilled. Okay. Here we go. I'm going to turn on the power supply one more time, okay? We're going to get about 160 volts here when we're on standby. I'm going to flip this guy right here, and we should, from my understanding, from our power factor correction, it needs to jump up to a certain amount. What is that? Who's that? What is that? Hold on. Oh, got it. MXP. You'll go crazy if you see my rubbish. Yeah, okay. Sorry, MXP. I'm sorry. Okay. So 120 times our 1.414, 169. Okay. So if we take our 120 volts and we multiply it by the square root of 2, which is a 1.414, we should see about 169 volts on these capacitors on standby. Okay. And we're going to see that with this meter, the Fortifix meter right here. Okay. Here we go. Flipping it on. Why don't we see anything? Why don't we see anything? Manual 5 volt. Why is it set to... Oh my God. Oh my God. Oh my God. It's not set to auto. It's not set to auto. It's not set to auto. It was on 5 volt. Now we're set to auto. We see our 160 volts, 166, 100 whatever volts, right? What's up, Rob? 12 inline connectors and 12 chances of failure or poor contact. Yes. You and manual range or voltages. Yep, that was it, Carter. You got it. Okay. So our input to our bridge rectifier, to our first coil, to our caps of standby voltage is operating correctly. We have 166 volts, which is about normal. We should see this voltage jump up to about 400 volts once I flip the switch. This means that our power factor correction circuit is operating correctly. Okay. Here we go. Let's see what our numbers are. Okay. 3, 2, 1. 363. I seen a 363 before it dropped back down. Obviously, it's shutting back down. Let's turn that off. Let's turn that off. Let's discharge the caps because yikes. Do you guys want to see what a normal, fully working power supply should be producing? Because I kind of want it just so as a comparison of what it should be doing. I know I'm saying it should be at 400 volts, but that's just based off of research. I should stop using the term research. That's just based off of videos that I've watched. I'm so scared. This is a dead one. This is a dead, but a different sense of the word dead. Okay. Oh my God. Okay. Get our red probe in here. Flip it off to the side. A black probe over here. We'll get our ground right Mia. And this over to Mia. And I'm not going to desolder the power switch. Okay. So you guys are just going to have to watch me jump it with a pair of tweezers. Is this all? Is this the working PSU or the faulty? The first one was the faulty one. This is going to be the working one, okay? What's up, John Carr? Forder fix. Hey, what's up, Forder? Okay, turning it on. We see that we get our 166, okay? I'm going to jump it. God, look at all these wires. Amazing. I'm going to jump it, and we're going to pay attention more towards what our capacitors should be at when it's a working switch, okay? So our last one, we got 367, okay? So let's pay attention right there. I'm going to jump it from AC/DC standby to our 5 VSB standby, okay? And for the love of everything, guys, please do not do what I'm doing. I cannot stress this enough, guys. Here we go. Power supply is on. Oh, I'm supposed to hold it. Damn it. Let's do that again. Let's do that again. But we seen the meter jump up to 400 volts, right? I'm supposed to hold it. That's right. Okay. Okay. And there. 404 volts, 405 volts. This is a power supply that is on. We have stable 12 volts right now. This is what we're trying to go for. This is the goal. This is a fully working PSU right here. Okay, so let's go ahead and shut it down. Let's shut it down. We're going to discharge these caps. Yikes. Unplug it. I'm still scared. I know it's discharged. I know it's discharged. Freaking out. Okay. Let's take this one off. Take this one off. And we'll put this one off to the side. Okay. Straighten out. Get cleaned up here. Plug this back in. Well, let's hold off on that. So, can we all agree? Our input's fine. Our bridge rectifier to our first single stage standby DC voltage at 160 is fine. We get our 5 volts. We get our 12 volts briefly. Our issue is with the power factor correction. Just like Sloth Tech said in the last video, the PFC. Can we all agree that the PFC seems to be the issue? Because I'm not 100%. I'm pretty sure. I'm like 89% sure. So where does that lead us? That leads us to here. This is our power in. These are the coils. All this seems fine. And that goes to HV standby +1 or plus HV plus, all that fun stuff. So if we zoom out, we go over to here. We go over to here. Where was it? It was down here. We see our HV standby plus, right? We have a set of resistors. We got some capacitors to another resistor, to a Zener diode, to this Q31 MOSFET. Maybe, I don't remember. I'm trying to remember as I'm doing this, guys. I'm sorry. Q31. So our Q31, hold on. I know you can't see. I know you can't see. I just want to remember where it's at, right there. Our Q31 is this guy right here, which comes over to here. Q31 to this little guy right here. But this should be fine because we are getting our standby voltage. So our Q31 should technically be A-okay. I can test these components, all these various components, to make sure that they're fine, which I have done. Oh, not that one. Off stream. They check out. They check out, guys. I could do it for you guys if you want. You guys just tell me if you guys want me to test anything, but I'm pretty sure they seem to be fine. Russ looking crisp. Thank you, Rob. Sounds reasonable. I thought you'd help Mr. Russ explain the rest of class, what's going on and where his problem lies. Shut up, meter. At Pico, I must say, I only said that since I've watched Toltec fix a bunch. Don't give me any credit. Well, you mentioned it to me, so I'm giving you the credit, Sloth. What's up, Ghazi? Look away, Ghazi. Oh, right, I see. I'm not letting Rusty take the class with Sloth Tech. Okay, did you ESR the big caps? I did not, JFix. I have not. By the way, no music today? There should be music. It should be very low music. Like I have it set almost like non-audible. But I can crank it up just a bit. But it should be there. Toltec is a freaking legend. I agree, 100%. Please take over. I'm no teacher. Okay. Okay. So what is Q31? Q31, from my understanding, is some sort of MOSFET transistor type deal. I don't know what this symbol means. I'm not 100% sure, right? What I do know is, let's say for an example, this one right here, Q5 is a MOSFET, right? So Q5 happens to be a MOSFET. So where did I see Q5? Hold on, guys. Sorry. Q5, right? This symbol is drastically different than this symbol right here. So this symbol to me, I could be wrong, is more or less going to be a transistor. Is that my, oh God, where's my note? Where's my notes? Damn it. I tried so hard to remember this stuff. Q is a FET or a transistor. Okay. So this is more than likely a transistor here, Q31. Correct me if I'm wrong. For the love of God, please correct me if I'm wrong. The music is on Twitch. No music, YouTube. We need to concentrate today. No music. It's low, so we can fully enjoy the inevitable bang. Q31 is a channel MOSFET. Oh, thank you for that, Ghazi. And you can tell just by the symbol on the schematic that that's a MOSFET. Because I would love to know. I can memorize that. I can memorize that symbol. You have your leg 1, leg 2, and leg 3. 2 and 3 are tied together. Versus over here. And Q5 I just picked randomly, right? We have our legs 1, 2, and 3, which are tied together with a Zener and a diode. Okay. All right, cool. N channel. Yeah, it's a MOSFET symbol. Okay. And that's the 2N 7002K model. Oh, Lord, you guys. Back over to here, to this. Okay, let's just keep going. This all ties together, right? Comes through IC 43 and keeps going to our DNP 012A. I feel like this part is fine, right? Our DNP 021A up to a point seems to be fine because we are getting our, where was it? No, I'm jumping around here. I'm jumping around. Oh, I get it. I remember. It's up here. We are getting our HVSB1, right? So this is the in, this is the fuse, these are the coils, this is our bridge rectifier. We are A-OK up to this point right here when we go to HVSB1 or SB+. So if we go down, our HVSB plus comes over to here, right? Goes through these components through our N-channel MOSFET. Can confirm it's some kind of MOSFET. And I can test these components right here, which I've done off stream, and these all kind of check out, right? So our IC43 comes up to, let me just make sure I can find it on the scope. Where was it? IC43. Now you can't see. I know you can't see. Q31. Where was IC43? It's somewhere around here. IC41, IC44, 32. Where did I see 43 at? I know I found it on here. Is it up here more? Oh my goodness.
SM4SH3RZ.
I could barely hear that. Why did I barely hear that? That should be way louder. Looks like an octocoupler. What are we trying to do here? We're trying to figure out why this power supply shuts off immediately after applying the enable pin, which is the 5-volt standby. Which I have an idea about why it is, but I'm trying to lead you guys there, right? I'm trying to get you guys to the same point that I'm at right now. IC43 looks like an optocoupler. So IC51, 52, 53. I know I've seen IC43 right there. This guy right here, which is inverted from all the other ones, indicated by this dot right here. You can't see, but there it is. Grab this plastic spudger. Our IC43 pin 1 inverted from all the other ones, okay? And this guy, to my understanding, an optocoupler seems to be more of like a diode type of deal. It might even be more like a double diode kind of a thing, if I'm not mistaken. I can take readings on this if I need to. I would probably need to pull it off the board to double check. But given the fact that we have our 5 volts and our 12 volts, when it kicks on, I'm not leaning towards this being an issue. If I'm wrong, you guys just let me know. But I think this is fine. Can confirm some kind of symbol. Thank you. Thank you, TFN. Okay. Wrong one. So if we continue on the path, right, we end up coming over to here, pin 11 on our DNP 012A. And our DNP 012A is going to be here. This guy right here. So here's our IC 43 and pin 4, which this is 1, 2, 3, 4. If you guys really wanted to trace it all the way down and around and back and around, goes to here. Our DNP 012A. You can get octocoupler tester because there is no electrical connection across it. Diode lets power flow through one direction. Octocoupler is like a photosensitive transistor switch that is controlled by an internal LED. It's a way to switch without physical connection between sides. Whoa. Very interesting. It has an LED built in. Whoa. Opto coupler. Yeah, that's what I thought it was. Everybody's typing octo. I'm pretty sure it was opto. Okay. Where am I at? Where am I at? Where am I at? Back to this. So I can check pin 4 to pin 11 to make sure that it's making continuity check. But I like I said, I think this part's going to be fine from HV SB1. All these components, I genuinely feel like those are going to be fine based off of the fact that we have our 5 volts and our 12 volts, right? Because HV, crap, what did that stand for? High voltage standby plus, right? I'm assuming that's our 5 volt. No, that could be our 12 volt. I think those are fine, right? So then we come to this chip, our DNP 012A, right?
Daro Orzip, thanks for the sub.
Why am I not getting that notification in my ear?
Rusty Russ is the best.
Dano, thanks for the sub.
Hold on, why are my Twitch alerts not... Can you guys hear those Twitch alerts? I can hear them, but they're not necessarily loud in my ear. Oh, yes, we hear. Okay, yes. Okay, cool. Thank you for the wait, that wasn't a Twitch alert. That was actually YouTube. Thank you for the sub. I appreciate that. Smasher, Dano, and Daro. Appreciate you guys. Okay, back to this, right? Something came up in the music is a little loud on the Twitch side. Really? Legend Nano is here too. To be honest, this is beyond my current level. I stick to retro stuff for now. Yeah, this is way beyond my skill level. Please do not replicate anything that I'm doing here. I am trying to learn. I can go pull a console out and do an HDMI port swap for you guys, but I said last stream that I wanted to try to tackle this and understand this, so that's what we're doing today. I'm pushing my knowledge and trying to understand things better. It's not going to be easy, it's not going to be fun, and it's not going to be perfect, right? Where am I at? So this is this chip right here, IC151, really correlates to our 5 volt and our 12 volt, if I'm not mistaken, voltages. But if we follow it along, like I said, I could test all these components all day long, and they test fine. All the values seem to be there, right? But if we continue on, follow along the schematics, it eventually creeps its way up past this, up to this chip right here, our DDA00AG. And that is here, DDA001AG. This guy right here is actually in charge at some point or level to our power factor correction control, which goes to our output pin on pin 5, the IC32, right? And again, I can test any of these components. I've tried to go this past week, guys. I've really tried to nail out a specific spot that's giving me issues, and I cannot find it, right? Based on the facts that we have our 5 volts, based on the fact that we have our 12 volts, based on the fact that we have our 160 volts up to our standby issue. The only issue that we're having is when we try to power it on, we only get like 160, 170 volts to our capacitors, which means our power factor correction is not operating correctly. We're not getting that 405 volts that we were seeing on our known working supply. So something in the power factor circuit is not allowing it to stay on, right? So if we take, I can change out this chip, sure. But if we just follow it along to our power factor correction control circuit, right? That goes along over to here, to this part right here. And again, I've checked this resistor, I've checked this N-channel MOSFET. I've gone all the way through. All of these components seem to be fine, right? Q73, let me just look, is right here. This is our Q73. Right here. And that goes up
Rusty Russ repairs is the
and
best.
along to our NCP 1608B, or IC41 basically, right? So our IC41 is here. Now this IC41 has some components that branch off. It's got our pin 1, which has a resistor capacitor. This array of resistors was brought up to me as faulty, as a known issue to be faulty, R25, 24, and 23.
Rusty Russ is the best.
No, guys, come on. I'm trying to learn. Okay, you guys are just chatting it up. Good. Yeah, chat it up. Faulty caps, test them. So I've taken off the capacitors, right? The big ones, these guys right here. I've lifted one leg before, and I tested it with my meter, and the capacitance values seem to be fine. I can actually take them off now and run them through this cheap, and I mean cheap ass tester. I don't know how reliable this thing is, right? I can't vouch for it, but it is a tester that I didn't have before. It is something that we can do. If you guys really want to take off the capacitors, wrong one, and make sure that they're in an okay state. Okay, so we can definitely do that. Our pin 2 is the control circuit that goes back over towards the other side of the schematic. Our pin 3 seems to be tied to the same area. Our pin 4 goes through a cap, a resistor, FB6, FB5, which is one of the MOSFETs. Where is it? Here. Right? FB6 and FB5. Now these MOSFETs, from my understanding, are actually in charge of switching that voltage from the capacitors to enable them. Now I've tested these components before. That's our FB6, right? Right here, these three guys right here. I didn't know how to test MOSFETs before, okay? So this is our FB6 or FB5, which goes here, which is our Q5. So our Q5 is this one right here. I struggled with testing MOSFETs because I didn't actually know how to test them. And I still don't understand them 100%, right? But I do know that if you're getting any kind of feed through them, as far as going in diode mode, come on, diode mode. um, through our, not the gate, the source and the drain, right? So if we get through here, open, which is fine. I'm just double checking, making sure there's nothing there, okay? And we go this way. So that's fine, right? That MOSFET checks out okay. If we just check it through this one, which I believe is the gate, 0.5, 0.7. To me, you shouldn't be getting any reading either way through, and that was a 0.48. Well, now it's 0. 0.4. God damn this meter. Turn that beep off. 0.48. Open. So the diode in there, right? Because these have a diode, is working correctly. Did you compare boards? No, we can definitely compare boards though. Okay, so this is a known working board. Testing through here and here. Open. Testing through here and here. This meter sucks. We get 0. Okay, there's our 0.4. This way. It's open. This way is our 1.1 volt. So black probe on the right, red probe on the top. So I'm just going to copy that right now. Oops. Can't see. I can move the meter if you want. We're getting 0.7 of a volt doing this right here. 0.7. Why is it so inconsistent? We do it this way. It's open. Do it this way. It's open. 0.5 and 0.5. If we switch them, 0.7, 0.7. So to me, it's open and open. Zero and 0.4. So here we're getting 0.47, right? This was just open. Are you kidding me, dude? Why is my meter so inconsistent? I swear I was just doing this and it was open. Okay. This is our known good one. So that's Q5, right? Q5 seems to be okay. I don't know why the freaking values changed so dang much. Think you need to remove the test? Gates and drains, yep, like number 33. Have to be careful as you can turn them on when testing. Oh. They're for switching the power factor correction. So from my understanding, when we get standby, we get our 160 volts DC to the caps. And then when we trigger the 5 volt enable pin, it triggers the God damn it. Hold on. It triggers the PFC, these guys right here, to increase the voltage, to turn on the voltage to these guys to have 400 and something volts, which allows it to have the required voltage to supply the 12 volts with the correct amperes. Because the caps are connected, really? Cheap tester, you would have worked to test MOSFETs, but you would have to. Yeah, I think we need to start removing some stuff, guys. I think that's really what it needs to be. Because like this is where I got stuck when I was trying to do it this whole week. Is these readings when I'm trying to read them are so all over the place. Let's remove some stuff. Yeah. This is our bad board, right? This has got the X on it. This is the area where we need to be. Our Q5 right there. So let's take off Q5. But in order to get Q5 off, right? Because there's a screw right there. There's no way I'm gonna get a screwdriver in there. I have to take off this whole heat sink. Thank you. In order to get this guy off, there's a screw back here, right? And I can't get the screwdriver back there, so I have to take off this whole heatsink. In order to take off that whole heatsink, talking here, 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 and then here. Compare diode drops between the working 16 pin and non-working. $16 That's going to be here. Our DA001AG IC32. If I'm not mistaken, right? Or IC32. Now for our diode drops, right? If we were to measure in diode, red probe on ground, our pin 10 is our ground, right? So our pin 10, pin 1, hold on, let me just figure this out. So we can see on this side, we're missing a leg, right? We have 4 down here and 3 up here. So from the missing leg with the side with 4 pins, it's going to be 1, 2, and 3. Okay? So we see we're missing a leg here. And so we have our four banger right here, 1, 2, and 3. So this should be our number 10 pin, which is ground. Can we all agree on that at least? I would swap PFC board. If that don't work, do this. I think MOSFET is fine, though often when they fail, they go short. Yeah. Put red on ground for diode drops. Yeah. But we can agree this is our ground from this guy right here. Our pin 10 GND ground. So this is going to be our ground. Pin 1 is 0.5, 0.6, 0.4. Now I'm going to stop right there and I'm going to measure these on the known working board. 5, 6, and 4, because I will forget stuff, right? So if we go to our known working board, or sorry, yeah, our known working board. This is our ground. Looking for 0.5, 0.4, sorry, 0.6, and then 0.4. So those seem fine. Then we have 0.2, 0.5, and our enable pin 2, which is tied to our pin 10. So that's 0. So 0.249 and 0.5. Going back over to here. 0.2, 0.5, and that should be 0. So this top row seems fine. We go here, 0.6, 0.6, 0.6, 0.6, 0.6, 0.5. So this is the third from the right, 0.6, 0.3. Going to here, making sure I'm not touching anything else. 0.6, 6, 0.6, 0.6, 0.6. This was our different one, our 0.5, 0.6, and 0.3. And this is our known working one. So our problem board, which is this one down here, all the pins on that chip are checking out. In diode mode, seem to be okay. Am I saying that correct? Continuity to ground. I thought we were doing diode. We can check continuity to ground as well. So this is continuity. Here's our ground. Yeah. No, continuity isn't. Okay. That was to test if the pin was ground. Oh, okay. Well, the thing with the ground, right? There's like isolated grounds. This input ground from our 120 to the bridge rectifier and everything is not going to read the same as the ground on this one, from my understanding, as far as even the same as the ground over to our 12 volt and 5 volt. This right here should be the ground. Oops. Come on. Point 0.3 ohms. So that's ground, from my understanding. So this leg is ground. 0.1, 0.2. I could zero it out if we need to. Pretty sure that's ground. Let's take off the caps, put them through the tester and see what they say. Then we'll take off the Q5 here and test those guys as well. And our fusible resistors are fine. These guys are all fine. Like they're not blown open or anything. Continuity 0.2. I don't remember what this one was, R11, but I think it's the same thing. It's fine. Yes, correct. Hot ground is separate from the safety ground. Okay. So this part's gonna be fun because I don't have a moo gun. Just make sure these are discharged, and they are. One cap. Cap 1. Forgive me for not knowing how to use this thing, but we're gonna figure this out together, right? So we put it into, let's go 1 and 3 on this little tester here. Lock it down. Test. Want to do something? Test in progress. Capacitance. Cap is 100 UF. Yes. ESR is 0.5 of an ohm. Voltage loss is 0.7%. That should be fine, right? That cap is fine. I'm going to say yes. Cool. On to the next one, which is here. We got our plus and our minus right there. Only put in capacitors in the tester if cap is fully discharged. Short out both legs before tester can otherwise die very quickly. Thank you for that, Ben. I did discharge the caps before I started messing around with this, but that's very good information to know. This negative is eating up all the heat. Come on. That is a lot of solder. A little bit more, just a bit more. Let's see if this one comes out now. One leg free, but not the negative. Wonderful, beautiful. Are there any other driver chips related to PFC compared, or compare those also on Diamond? Any other driver chips? Yes and no. Yes, I think there is. There is. I see. What was it? 41. Hold on. 42. And I can look in a second. I'm pretty sure it's just 42, but there might be a second one. Hopefully that's in enough. And remember, guys, this is a cheap ass tester. So like you can't bank on it. 137 UF. This is 150 UF on the capacitor label. So should be fine. Should be fine. These caps should be fine. So the other driver, IC42, which is this guy right here. If I'm not mistaken, this one right here, IC42, which is tied to IC32. So pin 7 output goes to the PFC controller, which is down here. We just checked IC41. Did we check IC41? I don't remember if we did. So IC42. Now, if we've already taken out the capacitors, is that going to mess up any of our readings, right? So we can check this one for diode readings as well. What's up, Dan? Welcome back. Russell Pairs. What's up, Sloth? Check diodes from other PSU to another. So we checked on the big one up here, IC32. All those diode readings seem fine. IC42, which is this guy, is going to be our next one to check. Replacing the small diodes. So once we get done with all these bigger chips and control chips and the bigger components, we can definitely go through and isolate any of these individual components. But I've checked what I could, and I didn't see anything crazy on the individual level. Time to drink more Red Bull. Yeah. So IC42, this guy right here. Our ground is going to be, pretty sure VDD. Is VDD ground? No, VSS was ground, right? VSS. Am I right about that? VSS? That's not ground. IC61. No. Okay. Wait. Which one was ground? I know VDD and VSS, one of them is ground, if I'm not mistaken, right? VDD versus VSS. VDD provides power to the circuit. VSS acts as the return path for the current ground. Correct, VSS. Okay. So we go back here, over to here. Our VSS is pin 4, which has capacitor 97 tied to it, right? So we'll just keep that in mind. Pin 1 on IC42 here. I'm not good at telling which one of these is pin 1, but our VSS has capacitor 97 tied to it. And that goes here, if we can kind of see. So this is going to be pin 4. That's going to be pin 1. This is going to be pin 4, which means our ground here, on the meters, yep, to here is our ground. And I'm checking at the negative terminal of the capacitor here, right? So this is our ground right here. So if we check pin 1, we are at open. That's continuity, son of a gun. Diode. Open. 2 is open. Now, is this because we removed the capacitor? Is that why we're getting open? Open on all of those. This is our bad board. This is our good board. IC42, this is our ground. Yeah, 0.6 of a volt. 0.6, 0.5, 2.5, 0.6, 5.6, and 0.6. So are we getting no readings on this one that we took the capacitors out of because the capacitors are missing, right? Or is this a bad chip right here? All of a sudden you want to give us readings now. Really? What the heck is going on? 0.6, 0.6, 0.55, 0.25. Did we see a 0.25 on the last one? 0.6, 0.55, 0.6. .25. Okay, so that's fine. 0.6, 0.6, 0.56. So all these seem fine on IC42, right? So IC42 coming from IC32 seems to be okay. Now there is another IC up here, IC61, which ties in to pin 1 out. And also pin 6, IN2, input 2, if I'm not mistaken, which also ties into input 2 plus, 2 negative, 2 plus. So before we get too carried away, let's just keep going with what we were doing, which was checking the caps. We are going to remove Q5, this whole heat sink right here, because from our power factor controller, IC41, we can check IC41 to double check, but our Q5 is right here, our Q5, and we're trying to get it out of circuit so we can actually test the MOSFET itself between the gate, source, and drain. Right? Maybe? Yeah. There's a voltage monitoring chip in the secondary, I think. Check that also in diode mode. So the voltage monitoring chip, would that be voltage monitoring chip? So we have a 12-volt regulated. Regular? I don't know. T2 coil, and then these resistors, this diode. It's IC61, the monitoring chip. Or here, IC101. Power ground. Nano Rust Toolberries, what's up? What's up, Tom? So I don't know exactly which one of these would be a voltage monitoring chip. It's hard for me to say, like actually understand this 100%, right? Zoom out just a bit. So our standby comes in, goes through this opto, hits the DNP 012A. And the DNP 012A, if I'm not mistaken, was DNP 012. DNP 012. 015. That's not the same thing. Why is it DNP 015? DNP 012. Power Management Forum. Da, da, da. Give me a data sheet. Come on. Alldatasheets.com. Come on. 015. It's not showing me a 012. We are repairing or attempting to understand a PS4 power supply. Datasheets.es. That's it. That's the one. It's taking me to another site. That's an ad. Not clicking on that. To a H, which is not the same thing. Specialized SOP 16 integrated circuit manufactured by Welltrend. Likely used in 12-volt power supply circuits based on troubleshooting references. So this, the DNP021A or 012A is the 12-volt regulator power management, 12-volt power management. Just based off of Google AI, fucking AI. Which we know is fine because we are getting 12 volts when we power it on. What's up, lead farmer? U-block origin light extension needed. U-block origin light extension needed. What the hell does that even mean? U-block origin light. Efficient content blocker, block ads, trackers. Oh, for the ads that I got. Oh yeah. Okay. Okay. Hold on. Voltage monitoring chip on the secondary. So the voltage 2 seconds, guys. I'm trying to think. I'm just trying to think. So the secondary side, would that consist of
Rusty Russ is the best.
this right here, our T2 coil, right? Would that mean everything on this side of the coil would be our primary side, this side of the coil would be our secondary side? Is that correct? Because if that is the case, right? If that is their secondary side, the IC101 and IC102 should be where we're looking. Ace and I don't block ads. We support content creators. What are we repairing? It's a PS4 PSU. Someone wants $20 for this chip. What are you guys talking about? Oh. Well, I do have other chips. I do have a couple of those chips. Okay, so then T2, right? 2 seconds. This right here is our T2 coil, right? This is what provides our 12 volts over to here. But I don't think this is our issue. I don't think these components are going to be our issue because we were getting 12 volts for a brief second when we powered it on. I think our issue is with the power factor correction, right? Which comes out of here, on our IC41. Did we check IC41? I'm already forgetting. No, we checked IC42. And so then our primary side for this would be feedback control, VCC, DRV. DRV, is that driver? Is that what that means? NCP 1608B. NCP 1680B. I see. DigiKey. What's up, Quaggle? You guys are getting ads? I'm not even monetized. Disabled resistance victim. What the hell is this? Up. I got a virus. Uh-oh. Bag out. Bunny.net. Why didn't I read that before I clicked on it? Son of a gun. It's already too late. I'm corrupt. It's my PC is corrupt. One semi controlled bridgeless totem pole power factor correction PFC operating critical conductor mode optimized for high density, high efficiency AC/DC applications like 5G power consumable electronics. So that seems like something we should look at. Which was IC41, which is here, right where we're at. Free virus, yeah. Okay, so then our ground is pin 6, which if our feedback has C91 connected to it, this is our pin 1, C91, which is going to be this guy here, which is very hard to tell which pin he goes to. But I'd imagine just straight down here. I'm in diode mode still. Hold on 2 seconds. Continuity from here to here. Yeah, okay, so this is going to be our pin 1. So that means 1, 2, 3, 4, 5, and 6. So this is our pin 6 right here. As we can all see, our pin 6 is ground. Let's just check with the negative terminal of the capacitor. And yes, that is a ground. Okay. So if we were going to go back into our diode mode, this is our bad board. Pin 1, 0.6, 0.5, 0.6, 0.3. So let me stop right there. We're going to go to our good board. Here, it's 0.6, 0.5, 0.6, 0.3. Those all seem fine. 0.6, 0.5, 0.25. 0.6, 0.5, 0.25. So IC41 seems to be checking out okay. We still need to check the actual Q5 MOSFET here and D11 diode, which is all connected to this one heatsink, right? Q5 there and our D11 here. So let me get this guy out and then we'll check and test we'll test the diodes out of circuit, the MOSFETs out of circuit. Jeez, man, this is racking my brain. Because all the ICs seem to be fine. All the ICs seem to be checking out okay. I think I have a relative in Nigeria that can help sign this up. I think I know a prince in Nigeria is always emailing me about inheritance. You guys are funny. Do I need to increase this? Because this is just a giant ass heatsink. He's not a robot, he's a ninja. Oh, Lord, Lord, Lord. I feel like I haven't said this in a while, but you guys please do not replicate anything that I'm doing on this PSU because I don't know what I'm doing. Okay? I am fumbling around trying to understand this. As you guys can clearly see, I have no idea what I'm doing. Let's get these components out and see what happens.
Rusty Russ is the best. Yeah.
Not true. Not true. But I appreciate that. Was that Yank? Thank you, Yank. Wait, Andy. Thank you, Andy. I did the Spark Big Cap experience on an old CRT monitor. So far, so good. No shocks
Rusty
yet.
is the best. Hello, hello.
Is that loose enough? I'd be very surprised if it actually was. Say right there. That one right there. How about that? Yes. That is very hot. Something's holding me back. Something's holding me back. That guy. Wait. I think I was wicking the wrong one away. Sloth. Appreciate that.
Sloth_tech tipped $5.
Hell yeah, Sloth. Appreciate that. Sloth with the $5. Straight to the cause, man. I appreciate that. Yeah, I think I was wicking away the wrong point. Yeah, that one. I need that one. Which actually doesn't make a whole lot of sense to me, but all right, we'll get rid of it. Okay. Almost. Is that gonna do it? Yeah. There she is. So the one with the 3 legs is for sure MOSFET. The one with the 2 legs, I'm pretty sure is a diode. If I'm not mistaken. Could be wrong. Could be completely wrong with all this. I know it's super dark and you guys can't see anything. I'm sorry. My microscope sucks. My lighting sucks. It's terrible. I know. Yeah, you guys can't even see any of the writing on here. Um, 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 um. What do you gotta add? What kind of filters are you supposed to add? Brightness? Ooh. Contrast? Ooh. Maybe that's a bit better. I don't know. It's fine. What's up, Undergirl? Can I be a mod? Not yet. Nano Rust Toolberries. I mean, maybe if like you stick around for quite a bit longer, who knows? But as of right now, probably not. Okay. All right. 20N60C3, right? Now, do I need to take it off of the actual heatsink, or is this fine, right? This is probably fine. So if we were going to check diode mode between here and here, we get open, which is fine. From here to here, wait. Here to here, come on. 0.43. Which is fine, if I'm not mistaken. Here to here, open, that's fine. Here to here, I'm not touching the probes. Open. Open. Okay, wait a minute. That's open. That's open. That's open. Not touching the probes. That's open. That's open. This is the only one that shows a 0.44 voltage drop in diode mode. Is that fine? Or should that also not show anything? I mean, we can put it in the tester. Good idea, Carthor. Do I have to take it out? Son of a gun, I gotta take it out. This is a MOSFET, which I don't really remember how to test, but we're gonna put it in 1, 2, and 3. Focus. Field effect, MOSFET. Focus. This doesn't really tell me if it's fine or not, right? Like this isn't going to say if it's failed. It can identify it, but without taking out the other one and comparing the values, how do we know that that one's fine? Peel that sticker. No, it's a free screen protector. It shows MOSFET, so it's a MOSFET, so it's working. Yeah, but that doesn't show that the MOSFET hasn't failed, right? Let's do continuity instead. If it detects the right components, it's a good sign. Yeah, it's a good sign. Outer pins, open, reversed, open. I know it's not diode. Pins 2 and 3 are fine. That way we're getting 680-ish. Nope, that one. 680-ish ohms. That is shorted together. Pins 1 and 2. Wait. Nope, that was just me touching my probes. Really? Okay, so that's fine. That's fine. Okay, hold on. So that way's fine. That way's fine. That way's fine. Reverse the leads. That way's fine. That way's fine. That way's fine. I think this is an okay MOSFET. The only reading that we're getting is here. But where were we getting that continuity between the 600 and something ohms? Why aren't we getting it now? Is it because we're using the meter and it's actually opening the MOSFET? Like, who was it that mentioned that before? Right there. So pins 2 and 3, like 2 and 3, 680 ohms. 2 and 3, 2 and 3. So the middle and the far right. So if this was back on, we're here, middle and far right. I know this is still in circuit. Middle and far right. That's middle and far left, far right. 1 and 3. Man. Diode on the diode, 0.35. Open. I can't tell, guys. I can't tell. I don't know how to tell if this is a bad one or not. There's a diode flows one way, not the other. Yeah, it's fine. Okay. Generally, a component tester would fail to detect a failed MOSFET, specifically if the MOSFET is shorted or open circuit, could still be leaky. Leaky? Leaky. What soldering iron am I using? I'm using the Finersi DWS 200. All right, well then, good boy, needs a diaper. All right, so then how about, just for the sake of testing, I'll pull this one off because we know this is at least a good one. We'll put it on there and we'll see what the results are. And if it works, then we'll know what the issue was. If it doesn't work, then we can have a reference point of where to look next, because the power factor correction is the issue. It's not giving us the full 400 volts.
Russ is the best.
Why can't I hear you guys with these fans anymore? Like, they all just got super quiet on me. If I turn that down. I used to be able to hear them real loud. I don't know what happened. I think our normal value here. Yeah. If the MOSFET was open, it would show MOSFET in the test. If it was shorted, it wouldn't show it either. Screw it. Let's just take it out. Let's just see what happens. They're fine for us on YouTube. Oh, okay. Oh, yeah, okay. You guys talk about those. Okay, good. Good. Well, they're not too loud then, right? If they are, let me know. But if they're fine, that's good. Let's just take it out. Let's just do it. Why not? At this point, we're just blindly swapping components, and like that wasn't the point of this stream, right? I wanted to understand how to read schematics, and I wanted to understand testing components and stuff like that. Like that was the goal, was to try to identify specifically which part failed. But I am up shit creek without a paddle. At least this way, we can test something and have a reference point. It'll take me 5 minutes. 5 minutes to do this. Hold on. Leaky MOSFET. So that's a new term for me. A leaky MOSFET. So based off of the name, leaky diode. So the diode isn't fully failed, but it's allowing some voltage to get through. Leaky essentially just means it's partially conducts between the drain and the source, for example, when it shouldn't. Does not endorse t-shirt, all sleeves, thanks, man. Yeah. So I got the shirt. I'm trying it out. I'm testing it out. I want to see what the better value of a shirt is, because like I've been comparing the shirts between like Joey and Nano, and I even bought the Fourth Wall does sell a muscle tank, a sleeveless shirt, and so I bought one of those. But I was not impressed with it. I was very thoroughly disappointed at the muscle tee, the sleeveless tee. So I got this one as well. This one feels fine. It's pretty cheap. Worst comes to worst, I'll cut the sleeves off of it. Is that it? that gonna be it? Hot. Motherfucking hot. I don't think it could go leaky and still survive. What's up, Anthony? Is it worth it to fix the PSU? No, not at all. These things are, PS4s aren't worth enough to make a profit on it. What this is a learning experience. There's no real value in me doing this. Like, even if I sell the PlayStation, like, okay, so I actually bought another power supply off eBay, and it was like for $16, and I thought for sure it was going to be like a dead one because they said it was untested. Plugged it in and it fires right up. So if worst comes to worst and I need to resell these, I at least have 2 working PSUs that I feel confident about selling the PlayStation with. Like, if I figure out this bad one and I get it working or whatever, I don't feel confident in selling it. Negative side goes over here just because I'm inexperienced with it, right? So like, I'm not gonna sell the PlayStation with a bad or with a repaired PSU. Like, you know, you're liable for stuff like that. So I have 2 working PSUs that I can put in there and resell them and feel confident about reselling. But this is more for experience and the ride, you know, going along for the ride of trying to figure out power supplies and schematic readings, different components. Like, for the past week, I've been trying to read and watch and understand various components about this stuff. And like, that's all this is for me. Like, there's no value in doing this. Okie dokie, shall we see if we get our power factorially corrected? That over there, that over there. This is going to go over here. Right there. This one's going to go right there. I mean, if this was like a PS5 PlayStation or a PSU, maybe there might be some value in it, but this is all just for my own personal knowledge. Here we go. We're going to plug that guy in. We're going to switch to DC. We're going to get our secondary meter here to monitor for our 12 volts. Those are secure. Those are secure. This is fine. This is fine. 3.2 volts is just what was left on the capacitors here. Discharge them. It should just creep right back up because that's what capacitors do. Here we go. 1, 2, 3. Power on. 167 volts. Learning from real world repair experience is priceless. Thank you, Nano. PSUs are generally classified as non-serviceable. Yeah. Nano Russ, if you knew what we were doing, could be a quick fix if a failed cap. Well, the cap seemed fine, right? I saw a leaky fuse on Paul Daniels' 600 ohm fuse. What? A leaky fuse? You guys are throwing me for a loop. Is my air compressor kicking on? What the hell? Okay, back at it. Here we go. 167 volts DC to the caps. 0 volts here on the secondary meter. We're looking for 12 here, and we're looking for about 400 and something on the regular meter. 1, 2, 3. You got to be dicking me. Oh, whoa, 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 and it shut back down. Okay. Okay. Turn that off. And off. Back on. One more time. And it drops back down. So the MOSFET's fine. Turn that off. Turn that off. Draining the cap so I don't get kilted. So what does that tell us? That tells us that Q5 area is working fine. This side right here. Q5, and what else is on there? Or D11. Q5, Q73, where's D11? Where was D11? D11 up here. So this side of L1, which is this guy right here, nope, that one, is A-OK. So then we need to start looking on this side. VDD SW2. IC41. Q73. So our power factor control comes from way over here. Where's it at? Here. Comes into this IC41. This comes out DRV and CS. Up to this point right here is fine. So if we were to look HV minus 5, HV minus 5, HV minus 5, which if I'm not mistaken was down here, HV minus 2. HV minus 3, HV minus 2. HV minus, what was HV minus 5? Plus 3. HV minus 5 right there. IC42. Okay. Oh, that's minus 6. Damn it. HV minus 7. Come on, come on, come on, come on. Minus 6, minus 6. HV minus 5 right there. Okay. So IC32. DDA001AG, which was the main chip for the power factor correction. Okay, hold on. Troubleshooting is an art. Just keep going and you'll solve and find errors in the future. Good that you're trying to learn schematic reading. Thank you, Pab. Could power factor correction be okay because it shoots up to 400 volts, but something else is shutting it down? Control F. Control F doesn't work on this schematic. I've tried. It's not like a real schematic. And like I tried downloading like Adobe schematic reader or whatever, and like no matter what, I can't find the software that uses Control F for this. I've tried. Could the PFC be okay because it shoots up to 400 volts, but something else is shutting it down? Okay. Did it go up to 400 volts? I wasn't paying attention to that one. Everything's fine. Everything's good. 160. 390. That's close. That was close, actually. So if power factor correction is fine, let's just say it is fine. This is off. That's fine. That should be fine. If power correction factor is fine, which is all of this stuff right here, right? Let's just say that this is fine. This is coming from here, which this is where I'm getting confused. IC42 and IC32. Which one is driving it, right? Okay, so if we go follow it, our output from IC32 goes to our output 2 of our IC42. This is our HV minus 5 that we're looking at, center diode, which ties in to the power factor control circuit. And I'm pretty sure we checked the diode readings of IC32 and IC42, which all seem to be fine. Could it be something else on this that's shutting it down? HV plus 3 is our feedback. Control CTCS, VCC, DRV, ZCD. What's up, Oldham? Quickest way is to blow out a scope. Quickest way to blow out a scope is checking a non-isolated circuit. Yeah. Your multimeter is not fast enough. So I seen it go up to 390, which is pretty close to the 400. So if we are getting the actual correct voltage on the power factor circuit, IC41, this FB, that's feedback, right? So if it's not getting, hold on, let me think. If the feedback is incorrect, if it's not seeing something that it should, would it also shut down, right? HV plus 3. What the heck is HV plus 3? HV plus 3 comes here. Resistors 18, 19, and 20. And goes to IC42 IN1 minus. But also ties into a bunch of other stuff, which I just can't get my head around. We can check like these resistors, 20, 18, and 19. This is fine. This is all dead. Eesh. Should be dead enough. We checked all the MOSFETs. We checked a couple of them, not all of them. This was for Q5. We checked the capacitors. Those seem fine. And Q5 was this guy right here, Q5, Q73. Like, how would you even check that though? Diode was fine. NTC1, RL 1.1, VDD SW2, SW1. I just don't know what these mean, right? So like, if we look up NCP 168B, NCP 168B, we checked all the lawsuits because they could go in protected mode. Can't help wonder if the guys watching that know about PSUs would warn Russ if he's about to electrocute himself or let him carry on. It's all about the learning experience. I think I'm fine, man. I understand when I energize it and there's electrical charge in it to discharge it. I'm fine. I think we're fine. But don't do what I do. Okay, guys? SW is standby wake? I don't know. I thought it stood for switch. Do you vape? What flavor is it? Yeah. It's strawberry chew. When I was 5, I stuck a butter knife in a 110-volt wall socket 2 times. He's a pro pretending to be a noob. Yeah. That's not it. That's not what we're looking at. Datasheet archive. Don't give me a virus. Please don't give me a virus. NCP 068B2R. What was it again? NCP 168B. NCP 168B. Datasheet.hk. Somebody. Anybody. FB. So this kind of looks like it. Yeah. Jesus, I wish I knew what that meant. FB. The FB pin is the inverting input of the internal error amplifier. A resistor divider scales the output voltage to VREF to maintain regulation. The feedback voltage is used for overvoltage and undervoltage protection. This controller is disabled when the pin is forced into a voltage less than that and a voltage greater than under voltage and over voltage, or is or is floating. HV minus 5. HV minus 5 was here. Where was it? HV minus 5. HV minus 5. I mean, at this point, do we just start at the input and just start checking components at the freaking single level? I mean, for all I know, it could just be one bad resistor somewhere down the line. HV minus 5. Where was it? HV minus 6. HV minus 3. I know, I just saw it, damn it. Minus 6. I wish Control F worked, guys. I really do. HP minus 5 is ground. So do we even care about that? Probably not. Why am I looking for that? Fun stuff. Hmm. Thank you, TFN. We'll see you next time, man. It's fine. I'll be fine. No worries. But I appreciate the concern. So we don't really care about HP minus 5. That's whatever. But it does go CT control. So like, what was CT? CT was control voltage. CT pin sources a current to change an external timing capacitor. Circuit controls the power switch and on time by comparing the CT voltage of an internal voltage delivered from blah. The CT pin discharges the external timing capacitor at the end of the time, at the end of on time. Let's see. So it is shutting down, right? So it gets almost 400, pretty much close to 400. So if the power factor correction circuit is working fine and it's still shutting down, what is not getting the signal to keep it running? Well, we have the 12 volt control IC, which is this one, DNP. And then we have the power factor control circuit, which is the DDA01. So what would cause it to not hold power? What would cause it not to enable the power to stay on? What is Q4 and Q3 in charge of? Q3 and Q4. Which are tied to DDA. Start signal here. And then D52, which allows T2, which is the 12 volt coil, to energize, which it does. So I would assume those are probably fine, but we'd never checked or tested them. Just watched back and it shoots up to 417 volts. So that's good then. It is correct power factor correcting. How far have you gone with following the circuit? So from the beginning of the circuit, like here, we can fuck it. Let's just start from the beginning. Let's just start from the beginning because we didn't actually check all this stuff, right? We actually didn't check. This is our line in, our line out. This is our fuse. These are our coils. This is our bridge rectifier. I assumed that all these are fine because that one. We have our in and our out, right? Just here and here. We have our fuse, which is here. And I'm in continuity. Fuse is fine, right? That goes through a CX1, whatever the heck a CX is, which goes to the coil FL2 here. And then it comes out through a CY3, which is these little capacitors, these little blue caps down here. CY2 to another CX, which is right here, which is to another coil. Which this should be fine. This should be connected, but not these here. So the coils aren't shorted, right? Then we get through all the way through to the bridge rectifier, which is this guy right here. This is ground, should not be connected, right? Hold on. Diode mode. Red probe on ground. 0.47. 0.47 and 0.47. Shouldn't a bridge rectifier not have anything going through? But this part's fine. Like we get our 120 AC in through the bridge rectifier, which gives us our 166 volts through this coil, and our standby to these capacitors, which is 160 volts. So I think this whole section is fine. Could be wrong. But to my understanding, from very limited understanding, that should be fine. HV SB1. HV, was it SB1? HSB plus. So then we come down over to here, which is our HB SB plus, which is these resistors here, right? R15, 16, and 17. Over to resistance mode. There's 16. Where's our 15? 15. Here, these are 2 mega ohms. Yep. 2 mega ohms. Yep. 2 mega ohms. Yeah. Which go to R45, which then goes to HV minus 2. So R45 is going to be 44, R45 right here. 510 kilo ohms. It's a little high, but it's not that crazy. To C64, which is this guy right here. I can't really test this unless I take it off, but it's not shorted, right? To R44, which is a 0 ohm resistor, to right there. Yep. And then all these components seem fine. We're here to this part right here, right? A Zener diode and another resistor R43. So if we go R43, it's right here, which is our 1.2 meg, and then ZD41, which is this diode right here, which we should have going through one way, but not the other. Seems fine. Then we get to our Q31, which is this component right here, right? Our Q31, and our leg 1 is not connected to anything. Our legs 2 and 3 are connected, but through a diode, right? So like, this is our leg 1. Should be nothing. Should be nothing. And then we should get something in one of these directions, right? No, don't touch the probes. Am I in diode? Yeah, I'm still in diode mode. Okay, so that seems to be working fine. And then we go up to these components here, right? D44 and R42. So we're gonna just swing to the left, check out these components, and then we'll come back over to this side right here. So D44. D44, which is gonna be right here. Didn't we just check this? .55 and open. So D44 seems to be fine. Keep going. R50. R50. Where is R50? Am I blind? R50, C65, which goes to the Q33, which is do not inventory or do not include. Q33 down here. So this is a missing, this is supposed to be a blank spot right here. And we have our R50 right here, which should be 2.7 mega ohms. Which is pretty dang close. Then R49, which is a 0 ohm right there. Seems to be fine. And then R48, which is another do not populate one right here, to C65, which is here, and no short. Kilo ohms and rising, okay? So these components right here seem to be fine. And then we branch off to HV -2 and VDD. But let's just take a look over here to this side, right? Because we got R42, 41, IC43, and then it branches off, okay? R42, which is going to be right here, R42, which should be 51 kilo ohms, yep. And then R41, this is what I was trying to avoid, actually just going through down line. R41 is over here, and this should be 51 kilo ohms, yep, looks fine. And then IC43, right? IC43, which is an ELO 113 or 1013, which I think are these guys, right? That's the ELO 1013. So we're looking for IC43, which is this one right here, to this component right here. Pins 1 and 2 are connected through a diode, right? So then if we go to diode mode, we should get a reading one way, but not the other, which is here. Okay, 1 volt, going back through this way. Open, right? So that's fine that way. And then pins 3 and 4, right here. Pin 3 goes to ground. Pin 4 connects to resistor 164. But this is another another diode. Okay. Let's see, pin 3 to ground, right? So this is 1, 2. This has got to be pin 3, right? So this is going to go to a ground, which we can just pick a ground here, I guess, to the ground of the capacitor. I don't know if those are connected or not. No, they're not. Okay. So then another ground source. How about this heat sink right here? Yeah, okay, so pin 3 does go to ground. Is pin 4 going to ground? No, I'm still in diode mode, which is probably fine. I don't know. And then R60 or 164, R163, 62, R164, where are you at? So this goes to R164. If we follow that trace as best that I can, R164, right there, R164 to here. Which is 750 kilo ohms. Yep, that seems fine. And that jumps over to 5 VSB-B, which is here. So everything up from the input to after the rectifier to this point here seems to be a-okay, right? Am I okay with that? So then we need to check HV minus 2. We need to check this feedback circuit. We need to check VDD, VDD1, and VSB -1. So like this could just go on and on and on and on and on. Oh, transistor output. What transistor? What? IC43. Oh, is that what that is? Okay. Okay. And that goes over to pin 11 of the DNP. And then VDD, which was VDD provides power while VSS acts for a ground, okay? So VDD and VDD1, those seem like something we should look at. And then FB, I'm pretty sure is like a feedback, right? So VDD, and it sucks that I can't do Control F. Look, I'll show you guys. Control F, and then if I type in VDD, nothing, 0 out of 0. And I don't know if I'm using like the wrong software or something like that. Oh, there's VDD. But I cannot for the life of me figure out how to do that search function. And so then we're back to the, no, this is not power factor correction. Okay, so this is new. This is something different. VDD comes in DNP 015. Whoa, IC31. IC31 was, if I'm not mistaken, right here. Because if we look, R144, R145, R146, and then IC. Oh, this is 131. This is not 31. My bad. My bad. Okay. Okay, IC31. We're looking for IC31, which was IC61, 44, IC32. Where was IC31? DNP015. IC31. IC31. So 101. IC151. Da, 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 da. IC31. Where are you? Where are you? That is connected to, let's just say, what are DNP015s? DNP015s. What are those? DNP. Yes. Oh, you know what it is? I think I remember now. It's going to be right here. This right here. If I'm not mistaken. Yeah, IC31 right here. So this is something we haven't looked at before, which comes out of here, which is our VDD and our feedback, right? So our VDD goes to pin 2, our feedback to pin 3. We can do a diode check on those just to see what the readings are. This is on our bad board right here. And our ground is going to be pin 1. You guys can't see. So our pin 1 is here. This is going to be our ground. Point 0.5, 0.6, 0.6, 6, 0.5, 5, and 5. It's our known good working board. Missing components though. 0.5, 6, 6. Yeah. So technically, all those readings are the same, which should be fine. Yes, hopefully. It's out F4. IC43, transistor output, opto isolator that uses the diode to trigger the base. Assuming you can't highlight the component / rail names, no, I can't. I can't do anything with the schematic. No type of highlighting at all. It's kind of limiting. It sucks. It really sucks. Okay, back at it. So IC51, right? This is our feedback. This is our VDD, right? I guess we could just check these components while we're here real quick before we jump over to the feedback. C25, which is this guy right here, C26, and then it goes to C27, which I'm assuming is some components on the back, okay? So C25. Great. is going to be these guys here. C26 are these two here. I can't check for capacitance because it's in circuit, but we can check to see if it's shorted to itself, which it's not. 13 mega ohms, 5 mega ohms. So that capacitor should be fine because it's not shorted, right? To itself. Could be wrong here. C28. C28, which is this guy right here. That's the diode. That's C. So this is C28. High resistance. And then ZD21, which is this guy right here. Open. 0.5 voltage drop. So this whole side right here of VDD is fine. Then it breaks off to HV02 or -2, which is another thing we got to look at. But going off of pin 3 to this feedback circuit right here, we have an IC51, C235, another Zener diode 202, and like I can pull these off if you guys want to, so we can check them on the tester. But like, we're gonna be here all day long. I mean, we're already here all day long, but like, at what point do we start pulling components off and checking versus not, right? I've been able to make a PDF searchable before using an OCR tool. It's another acronym. C235, 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 or ZD020 right here. Another one of these guys. 0.24 and 0.6. Okay, so correct me if I'm wrong, but a diode should not be showing in both directions. 0.6 and 2. It's a 9-volt Zener diode. You can do in circuit depending on what it's connected to. Oh, okay. It's in circuit. Okay. OCP is an optical character recognition. Optical character recognition. Is that something I can look for? Like, is that something that's optical character recognition? Amazon Web Services, really? Thebestpdf.com. Okay. Check the optocouplers and diode mode. Okay, we can do that then. We can absolutely do that. Search PDF. PDF to searchable. PDF to searchable. And the first one coming up is Nutrient.io. Reducto AI. I'm going to hit Amazon. Let's see what Amazon does. Free account. No. Adobe, free PDF editor. No. Make PDFs fully searchable. Ugh. I'm clicking on a whole lot of links, guys. Is it I love PDF? Have you powered on and checked for any voltages? Yeah, so we are getting all of our voltages to an extent. Like, we're getting our 160 volt standby to the caps. We're getting our 5 volt standby and when we power it on, it jumps up to just about 400 volts on the caps, which is our power factor corrected cap voltage, and we're getting 12 volts very briefly before it shuts itself off. If you want, I can send the link. Yeah, let's do it, because when I have to look at that PDF, man, it's killing me having to find SW minus 2 or whatever. All right, let's see. You gave me a virus. I'm just kidding. Convert non-selectable PDF. Drop PDF file here. Okay, 2 seconds. Let's see. We're gonna go downloads. We're gonna hit this one and click on OK. And apply. Recognizing. PDF is now selectable and searchable. Downloaded. Cool. Open. And let's just see. Ooh. That makes it very blurry. Control F, VDD. Anything highlighted? Like VDD was here. I don't know. Was that VDD? I'm pretty sure that was a VDD. Yeah, that should be highlighted or something. Oh, right there, I guess. Okay. There's one that's highlighted, but man, that is grainy as hell. Search there and look at the original. Okay, yeah, cool. So we'll do that. We'll pull this over to come on, here. And so, but it okay, it's fine. It gets this VDD, but it doesn't actually pick up on this VDD, which is just fine. It's fine. What did it do to the PDF? I don't know. Okay, back to the what Ben said. The optocouplers in diode mode. Did you check diode drops on the 16-pin chip on the secondary? Diode drops on the 16-pin chip on the secondary. 16-pin chip. Okay, so secondary, when you say secondary, Ben, right? I'm trying to understand what that means, because 1, 2, 3, 4, 5, 6, 7, 8. So this is a 16-pin, and this is a 16-pin. This 16-pin is in charge of the power factor correction. This 16-pin is in charge of the 12-volt, 5-volt voltage regulation, right? When you say diode drops on the 16-pin chip on the secondary is the low voltage side of the transformer. So that would be this guy right here, the low voltage side. Did we check diode drops on this? I don't think we have. IC 151, probably not. We'll do that in a second. We'll do that next. And then check optocoupler and diode mode, right? So we have a few of them. The one that you guys can't even see. Power factor correction, 12-volt, 5-volt standby voltage regulation. Where were we at? We were here at this feedback, right? DNP 051 IC31, which is here, IC31, right? We just checked voltage drop on this guy. They seem a-okay. So if we go back over to here, our feedback circuit off of pin 3 does go to IC51, which is one of those opto couplers, right? So IC51 is going to be 52, which is going to be this guy right here, IC51. Voltage drop. So if we want to do diode mode on this guy, just trying to wrap my head around this. I'm going a little bit too fast. I might need a Red Bull. Pin 1, which is, it's super dark, I'm sorry. Pin 1 is this guy right here. Over to pin 2, which is this guy right here. So if we were to check in diode mode, right? I know our ground, where's our ground? IC 131, pin 2, pin 3 goes to ground. So IC 131, which was here, IC 131, and our pin 3 goes to a ground. So one of these is going to be ground. And I'm just trying to make sure I get the right ground because there's like 2 or 3 different grounds on this thing. On optocouplers, you check between the 2 pins on one side and between the 2 pins on the other side. Definitely, or don't have to identify the ground for them. Really? Okay, so let's go this way. 0.5, and we'll switch this way. 0.7. Am I in diode mode? I am in diode mode. Check the known working board. 0.5, switch the leads. I know you can't see, I'm sorry. 0.7. That's the exact same thing that we just did right here. 0.5, or 0.6 now. 0.7. Cool. This way. It's 2 volts. Climbing. This way. It's 0.6. So we go on the known working board. This one is 0.2 and climbing. This way is 0.6. Since we're doing that, should I just check all these guys anyways? Because I've been trying to follow the schematic in the path, and I'm just so fucking lost. 2.8. Open. 0.8. 0.7. Compared to known good. Yeah. Don't have to identify. Okay. Yeah. Okay. So I'm not gonna keep pulling it into frame. This is the one that I'm gonna be showing you guys is our bad board. The one that I'm gonna be pulling the secondary values from is our known good board, right? So I'm going to keep the orientation the same. Red probe on this side, we're getting 0.7. Going over the known working board, this side right here. Oop. Come on. 0.7. Switch the leads. 0.6. The working board, 0.6. We go on this side.
Florinda Net FDB, thanks for the sub.
Thank you for subbing. Appreciate that. 0.29 this way. Open. So we go this one. 0.27, 28 and climbing. 0.29. And this way. It's open. So then we're going to go this one. Open. And this way. This is 1.0. This way. It's open. Back around this way. It's 1.0. This way. It is about 1. It's 0.9. This way. Open. We go this way. 0.9. That way. Open. feel like we already did this one. 0.8 and climbing. 0.7. 0.8 and climbing. 0.7. Whoa. 0.8 climbing. 0.5. 0.8 and climbing. 0.5. 0.7. 0.7. 0.7. 0.7. 1.3. 1.3. 1.3. 1.3. 2.6. 0.8. 2.6 and 0.8. That's it. That's all of them. That's it for the optos. All of them seem to be checking out A-OK, at least on the board. All right, 16 pin on the secondary next. The output diode for the 12 volt rail is not shorted. 16 pin and the output diode for the 12 volt. Okay, so let's see, where is the output diode for the 12 volt? This guy right here, I'm assuming. Output diode here. D131. Is that what we're going to be looking for? Output diode. D131. D131. This is D132. D133. D131. We're in diode mode. 0.29. 0.5. 2.9. 0.5. Was that 2.9? Yeah, 2.9. Okay. This is a different power supply layout. There is no single rectifier output diode. My bad. Oh. 16 pin. Okay. 16 pin. Here we go. This is the DNP 012A, which is, what was it? This one. IC 151 right here. And our ground is pin 12. Pin 10 is not being used. Okay, so pin 12. We go 1 through 8, 9, 10, 11, 12. So this should be our ground right here, right? We'll do our red probe on ground. 0.5, 0.5, 0.2 and climbing, 0.3. 0.2, 0.5, 0.5, 0.5, and 0.6. Okay, so pin 12 on our known working board here. 8, 9, 10, 11, 12, which is this one right here. Yep. 0.5, 0.5. That was our 0.3, right? Yeah. This is our 0.2. Okay, and the rest of these should all be 0.5. Cool. And then just because we're already here, we'll go with the pin 9, 0.2. Our pin 10 is not connected, it says, but we're still getting 0.6. 11. Okay, so we had 2, 0.6, 0.5, 0.2, 0.5, 0.2, and 0.46. Pin 12, so this is 9, 10, 11, 12 is this guy right here. 0.2, 0.6, 0.5, 0.2, 0.5, another 0.2. I think that was fine. And then a 0.46. So that chip seems fine, right? Compared to the known working board, that should be fine. I'm telling you guys, like, I cannot find the fault at all with this thing. Everything seems to be a-okay. I just don't understand. Now, there was one video that I saw that related back to, where's it at? These resistors here. R23, 24, and 25, which comes back to the power factor correction circuit, IC41 feedback, right? Somebody mentioned it in the chat last stream that these are kind of like a known issue. I've checked these before and they're funky. They're real funky, right? They are these guys right here. 23, 24, 25. These should be reading 0.27, right? 0.27 mega ohms. 1.3. 1.3. And 1.3. That's our bad board. Our known good board, which is why it's like I didn't want to chase this one. 1.6. 1.6 and 1.6. So they're not exactly at the 2.7 that this schematic is showing, but even our known working board isn't at 2.7. But it's been an established issue that I've seen before, where you need to rotate them off the board. You need to get them halfway hanging on the board to measure them correctly. What's up, Ace? Is that different power supply layout? Oh, wait. There's no single rectifier output diode. My bad. Yeah. What's up, Ace? So I can I can rotate these resistors and check the values for them when they're off out of circuit to make sure that they're the correct value. But I've measured them before, and like once you start measuring them, they go crazy. They get funky. So you can see now we're at 5.9 mega ohms. I have no clue why all of a sudden the resistor value jumped up to 6 mega ohms. I cannot tell you why after you measure them once,
Is the best.
they do that crazy. They do that craziness. And we're at 6 mega ohms. This is the same resistors on the bad board that we just checked that we're at 1.6 or whatever the hell it was. MDL, what's up, Reflex? So at the risk of a long shot, just take them out of circuit and measure them. What's up, Dan? Still struggling over here,
Who is
man.
the best? Rusty Russ is the best.
Okay, stop it. I really don't think this is going to be it, though. Have you checked the thermistors? The thermistors, if you're talking about the, what do they call these? Fusible resistor? Is that the same thing? I've been listening. The resistor is never supposed to be higher in circuit than out of circuit, but I doubt they all failed the same way. Meter playing up after charging caps with meter. Ah, yeah. Mr. Thermistor. What's up, Jason? The fusible resistor, is that what you're talking about? Thermistor, Oldham? Thermistors. Thermistors. NTC 151. Oh, I don't think we have checked that. Where did I see that at? You know what? Might better just to find it on the board because I'm pretty sure I've seen those. NTC 41. Which is just the heat sink. Where did I see that other NTC at? First thing, I would remove all electrolytic caps one by one and measure them, especially the small ones connected to the startup capacitors and driver chips, because driver chips cause problems when out of spec. Sheesh. See y'all. Gotta go to the post office. Good luck, Russ. Later, Nano. Appreciate you for hanging out, man. Really? All these little guys? I mean, there's really not that many. Okay, hold on. What was NTC 151? Let's use our cool, nifty
Rusty Russ is the best.
NTC 151. Let's see what happens. Nothing. How about any NTCs? Am I in the right one? Yeah, it's blurry, so that should do it. Yeah. Oh, Lord. Really? The caps, huh? NTC. Where did I see the NTC? I know I seen it somewhere. Was it down at the bottom? NTC 41. Rusty Russ is meh. The output filter cap shouldn't matter. The output filter caps. Output filter caps. Okay, hold on. One thing at a time, one thing at a time. Where did I see that NTC? Okay, so this is the symbol that we're looking for, right? This guy right here, NTC 41. Is 151 an actual part on this, or is that just like a default number that most thermistors get? NTC 41, which was, I know you can't see, I know you can't see. This guy right here. Which is 500K ohm. $22K ohm. 22K ohm. Is that just like a normal rated value when it gets hot? Thermistor 22. And well, that was 500. What happened? Hold on, hold on. I did see a 500 there for a second. What happened? $22. Crap, it's already 1 o'clock. How is it going by so fast? $22. So that's the same. Those are the same. Lift off of IC 151 on schematic. Left of IC 151 on schematic. IC 41. Here's an NTC 1. IC 151. Wait. 151. This is IC 51. Not the same. Not the same. Russ, look at the chat. I'm looking at the chat. What's up? 666 sub. Oh, yeah. East side, let's go GTA wrong. It's 9 p.m., 4 p.m. for me. Okay. I'm surprised he has this many subs. I am too, Jason, every single day. Left of IC 151 on the schematic. Okay, where's 151? IC 151 on the schematic, which I can't even use our new cool thing, IC 151. It's not letting me. How about this? Control F, IC 151. Nothing. Nothing. Okay, hold on. IC 61, 101, 102. God, I wish I could just look up exactly where it's at. IC 43, 151. Oh, okay, right there. Left of it, right there. IC 151. Okay. DNP 012A. So that is this guy right here. DNP 012A, NTC 151. NTC, almost there, which is connected through pin 5, jumper 6. So pin 5, 1, 2, 3, 4, 5. J7. Right there. N51. Oh, you need a better PDF viewer. I agree. Search in the PDF, not the browser. What? Control F. Yeah, okay, so it's taking me to the browser then. Is that what that is? How do I search in here without it taking me to the browser? don't get it. I don't get it. He needs Adobe. I tried to download Adobe before this happened, and like I got a free trial, but then like it still didn't let me do a searchable thing through it. This is supposed to be another 500K right here, and then yeah, it was just all bad. 69K ohms are going to be the same. 69 giggity. And if we look on our known working board, 68. Come on. $68. So that should be fine. Stay fine, but it's the same value. Russ, would you share the schematic? I work on these sometimes too. Yeah. I can share it. It's just a schematic that Mr. Toltec had sent me. He says it's not one of his, so don't like treat it as the Bible or whatever. But it is just regular schematic here. Downloads. Is this gonna work? I was talking about PDF viewer. I know. It's terrible. Terrible. It's not letting me copy and paste. I share a pro version with you on Discord. What? Ooh. Uh-huh. Doing it. Downloading it. Portafix meter not metering. Oh, because I'm on, yeah. I'm doing other stuff on that browser. How do I? No, his website's fine. It's up and running. How the heck do I post a link for this? Extract it. Run it. Malicious file? Oh, damn, JFix, what are you sending me? Windows malware warning and run it anyways. Ignore Windows malware warning. Sensitive personal data may be at risk. Oh, God, I've downloaded so much shit today, guys. I've clicked on so many links today, guys. Oh, my computer's screwed. Ignore, yeah. Windows cannot find blah, 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 blah. Make sure you type the name correctly and try again. Oh, crap, it's gone. Where did it go? Where did it go? Well, that disappeared. Quarantined. Oh. What the hell does quarantined mean? Oh my God, you guys are killing me. I'm learning so many new different things, guys. I got about an hour left. Crap. Rob, are you on anybody's Discord? Because I can't figure out how to post shit in my own chat.
Who is the best? Rusty Russ is the best.
It's what antiviruses do to viruses. Oh, wow. Do I even have antivirus on this thing? Windows. Viruses. Quick scan. Ransomware protection. I'll figure that out later. I'll probably have to figure that out later, JFix, sorry. Nano Discord, okay. All right. So you are on Discord. Is your name the same on Discord as have we ever sent messages back and forth? Did he send you a version? I don't know. I'm not at liberty to say anything. I'm just here. Rob. Okay, let's see if I can find you. 2 seconds. Sorry, guys. 2 seconds. So I see 2. Rob Xerix. Yes, it's on my version and patch can show as a false. I don't know what that means. Sorry, guys. This guy? Go. Yeah, that guy. Come on. This guy. And I'm going to add you as a friend. And where is the message? This one. Here. There. Over to here. Over to there. And there. Okay. That's done. Back over to this now. What are we doing? Oh, Lord. We checked NTC 151. That was fine. At the risk of running out of time here, guys, do we just change out these chips? Because I have them. Freaking have them. DNP012A. Double DA001AG. Power factor chip and voltage regulation chip. I really wanted to pinpoint the issue. I really wanted to find what the problem was before we just keep swapping out parts, but everything seems fine. I don't get it. Yep, change them. Can't break it if it's already broke. Received. Okay, cool. Yeah, this one is definitely not just a sig. I have a second power supply, guys, that's faulty that I wanted to crack open after we fixed this one. Ah! Sorry, I didn't mean to yell in the mic. Sorry. I thought, sure, maybe an hour, 2 hours, we'll get this one knocked out. Oh, freaking A, we're on almost 4 hours of the same bad power supply. I would start swapping the 15-pin one. Okay, 15-pin one. That's this guy. Double D. This one right here. I'm going to listen to Ben. It's either that or we pull off all the caps and check values of the caps. Which we can absolutely do as well. Yes, you're absolutely right, cows. You didn't miss a dang thing. All right, so what's going to be the best way to do this? I don't know if I want to use hot air. I really don't think I should use hot air. Giant caps, hot air, right below. Probably not the best thing to do. So yeah, soldering iron. So this is gonna be fun. This is gonna be a-okay, guys. We're gonna flux it. We're gonna add. Probably don't need flux right now, but we're gonna add some leaded. We're gonna wick away as much as we can, and we're gonna try to lift as we wick, or lift as we pull. Time just needs to stop. This is ridiculous. About as good as I'm gonna get it. All right. Tweezers. Here we go. Time out. Time out, time out, time out, time out. You're lying to me, cows. I'll time you out. Abuse of commands. No, that can damage the pins. Oh. Put so much solder that the pins are all bridged. Then you can take it off with a soldering iron, heating both sides. Oh, that's what you were trying to tell me, cows. Okay. You can also use low melt. I haven't removed many of those with hot air and it never bubbles. Well, I'm not worried about the bubbling. I'm worried about the giant caps underneath. So we need just a shit ton of, well, I probably shouldn't use flux if we're just trying to bridge everything. This is gonna get real ugly, guys. Real ugly before it gets pretty, okay? Real ugly. When I want to bridge something, it doesn't bridge. When I don't want to bridge something, it bridges like crazy. I'm not lifting. I'm not lifting. I'm just slightly putting pressure. Nothing crazy. This is not going to work. There's no way this is going to work. More. More. There's glue under the chip. Oh no, don't tell me that. Oh god. Oh god. Oh no, I fucked up by doing that. For the love of God, please be okay. Please be okay. Please. Watch out for knocking other things off with that much light. Yep. Mm-hmm. Uh-oh. Headphone died. That's how you know I've been streaming too long. Headphones are dying. Why do I hear myself? Um, it's very strange. All right, is that better? Yeah, okay, so I don't hear myself anymore, but I was just kidding, cows. I'm sorry, I love you. Almost there, guys. Almost there. Almost there. Absolutely terrible. No rip pads. Yeah, W. Any missing components? Anybody see anything go flying? I think we're okay. Good enough. Oh, can't clip. What do you mean you can't clip? I didn't disable clips. Don't forget Blobenstein on the dial. Thank you. Uh, That way. What the? Is that a cap? Or is that just blob? That looks like a component. Oh no. 2 seconds. Flashbang. It is a component. No, it's not. What is that? Yeah, I think it's just a blob. I think it's just a blob. I'm looking at it. I think it's just a blob. Yeah. Yeah. It's gone anyways. Yeah. Oh Lord, here we go. Make sure the whole top row is matching before you solder. Yes, thank you, Ben. Solid advice. I'm gonna say right about there. Just gonna tack it down one. All right. That looks pretty good. Can we all say that looks okay? Looks pretty good. Somebody tell me it's okay. No, I mean letters on the chip. What? Oh. Just clean this one up. Very hard to see. That is terrible viewing angle. That's not telling us anything. Almost. D-A. So close. Man, this chip's cooked. On the known working board. We're at a DDA001GA. On the board we're working on, DDA001GA.
Dukin29, thanks for the sub.
I think they match. I think they're fine. I think they match. There's an A and a B version of the chip. I think we got the AG one. Thank you for the sub. I heard it. Missed it though. Looks same to me. I paused. Thank you. It's PS fine. Just vibe solder it on. One last check on the questionable one. DDA001AG. Yeah. Okay. Can confirm. I thought it's a PS5, PS2. No, this is a PS4, buddy. Sorry. This is an old one. I can't afford to work on PS5s. I'm poor. Maybe one day. My authentic Mr. Yang toothbrush with the white bristles. That's how you guys know it's real. Not none of that red fake crap. How's it look? Looks pretty solid to me. Oh, Lord, here we go. Full send. Do we care about hooking up all the meters and whatnot? I got 30 minutes left, guys. We might as well hook up the meters. Send it. Okay, hold on. Hold on. I want to thank everybody that's been here and hanging out. I really do. So I'm going to send you guys 5 gifted memberships. You get 10 a month. I'm going to send out 5 right now. Everybody's been hanging out. Good luck. Hopefully you guys win some. Here we go. And while I'm doing this,
At Ronson Wagner became a member.
we'll do a poll. Will it work?
At Rob Xerix became a
Hey,
member.
Rob got one. Cool. Am I at?
At JDMCS became a member.
Let's make some room. Get you up out of here.
At Shane's Stuff 1321 became a member. At Lalarin became a member.
Oh, all this stuff, guys. Here we go.
At Dan-V3 I became a member.
Damn. Hell yeah. Okay. Is that a bronze one? Dan, I think that's a second membership, a second month membership right there. Okay. We got our 12-volt power meter here. We got our capacitor meters here. So I'm going to plug it in. We should get about 160 volts on the caps. Hello? Caps? Where's the meter? Where's the voltage? Oh, I haven't plugged it. I haven't turned on standby. I'm going to turn on standby. Okay, here we go. 160. Dan, thank you for that. I appreciate it. um, mm, 2 seconds. I know. I know. I know. Give me 2 seconds here. Seen no power on. Am I still live? Can you guys still hear me? Yes? Okay, cool. Something happened. I don't know if you guys seen it or not. Let's go ahead and end the poll. 52% no. You guys were right. 52% said no, so you guys win. Let me disconnect here. Let's discharge. Oh yeah, nothing there. Cool. Let's go into continuity mode. Okay, so our fuse is fine. Let's try turning it back on. Back into DC voltage. Powering it on. We're getting 1.8 volts on the caps. I'm actually getting no power on my variable transformer here. She went poof. My fuse went poof. It blew my transformer, guys. Oh, that's unfortunate. I need to buy more fuses. Yeah, that
Who
protected
is
me
the
from
best?
going offline,
Rusty Russ
exactly.
is the best.
Yep, the fuse went on the Variac. It's only a 5 amp fuse. Crap. So something didn't like it. We are dead. No power, no voltage. I don't know why it happened. I don't know. I can't tell you why. All we did was change out that one chip. Let's take a look at my soldering job and see if there's anything crazy that I missed. Maybe there's some bridging going on. Seem legit to me. They seem fine to me. This is dead. There's nothing on, no charged caps or anything. So I'm okay. Don't worry, guys. All the legs seem fine. Why on earth would this have tripped my electric? The fuse is still fine on here. Bad chip from China? Possibly, yeah. I mean, very likely. All of us are dead. Spider, what's up? I worked on an Apple power supply. It had a burnt IC. Ordered a new one from AliExpress. They sent me a fake chip. Is that the A version of the chip? Wasn't there a B chip installed before? So this is the chip that I got from China. 100% new. Double DA001AG. DDA001A 15 SOP chipset. That is an A. What was on here is this is the same exact power supply. This one's the working one, the factory one. Double DA001AG. Double DA001AG. So it should be the same chip. I think it's a fake chip. Does the old one not have a BG? No, I don't think so. Some China chips have the writing upside down. Thank you for that, Simon. Double D, nice. Old chip was it's an AG, double DA. FERC. Do we do it again with another chip from China? Do I order some from a reputable source like Mauser or DigiKey? Mine had a BG, didn't know. Don't use the Variac. That's the only thing that kept me online. Let the magic smoke out. Tip to the bowl. Check for shorts. Toltec coming in with some actual real deal advice. Check for shorts. Okay. Not saying that your advice isn't reputable, Ben. You've been an amazing help with this so far, man. I really think they're fake chips. Even the font looks different. So for shorts, crap. We're looking at not that one. This guy right here. Pin 10 is our ground. Right here. Pin 10. Is there going to be our ground? MOSFET or something blue, otherwise there wouldn't be a high current draw to blow the fuse, right? Check bridge, recheck bridge. Check the new chip for shorts before installing them. If the fuse blew, something had to have shorted. It was the fuse on my Variac, my Variac. So pin 10, this is going to be our 14. This is our 12. 11 and 10. So this is our 10 right here. We're in diode mode. 0.2s, 0.4, 0.5. And I don't remember what any of these values were from when we last measured. I'm just looking for anything out of the ordinary. Which they all kind of seem fine to me. Pin 9. Oh, it ties in with pin 10, so that's fine. Need to get a dim bulb tester. Yeah, I agree. Resistance mode. Pin 10 to ground. So we know we can check for ground here. That should be also tied to ground. 9K, 700, 265K, kilo ohms, mega ohms, mega ohms, kilo ohms, 32 kilo ohms, kilo ohms. So nothing on here is shorted. Our neutral is here, positive is here, mega ohms. Our coil, those seem fine, those seem fine. Kilo ohms. Our other coil down here, mega ohms, mega ohms. That's fine. That's fine. So now our bridge. This is our ground right here. Mega ohms, mega ohms, mega ohms. I think that's fine. Check MOSFETs. If blew the fuse, then vary that quick, something major probably shorted. Okay, all right. They're in circuit. And that's probably fine. Kilo ohms, mega ohms. Am I in the right reading? Should I be doing this in diode mode? Because that's my meter. Because from my understanding, you shouldn't be getting any readings through a MOSFET, right? I mean, that is high resistance, but let me see. That one, this is on the working board I'm looking at. And we are getting a bunch of resistance values. Boogers. On the caps themselves, they are orientated in the right direction, so that's a positive, I guess. And all we did was change this guy out and put the caps back on in that one chip. The probes on my meter aren't touching anything, so that shouldn't have been an issue. The switched button that I have for 5 VSB and AC/DC standby is not bridging anything from what I can see. So that's probably fine. Let's go into diode mode and check the MOSFETs again, right? We changed out these ones right here. I don't know which one is gate, source, and drain. I think the first pin is going to be our gate. So that's open. Should be fine. What is this? Stream Boo! Goodbye. Everyone is seeing a bridge near the chip. Wait, whoa, 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 whoa. R11 looks damaged. I see a blob. Check your DMs. What? What? Everyone's seeing a bridge near the chip. What just happened? Oh, I banned somebody, Rob. Let me go to the Discord. Sloth. What's that? What's that? Resistor 91. Is that supposed to be there? This is the good board. I think it's supposed to be there. I think that's okay. A good spot. I mean, it has to be this issue right here, right? This is the last thing we did before we had problems. So like, before we just deep dive into this as looking for another fault or an issue, like, you should always go back to the last thing that you did. And the last thing that we did was this chip. And R11. There are two above it bridged. That? I think that's okay also. Yeah, I think that's okay too. Where's R11? Was that R11? Reblob it. Did you double check R11? Okay, where's R11? Why am I missing? Where am I missing? Where am I missing? Where's R11? Why can't I find R11? I'm getting off the plot here. Where's R11? Come on, come on, come on, come on. It's already 2 o'clock. Come on, come on, come on. R25. Flip the board. Big resistor, front side. Flip the board. Big resistor, front side. R11. Um, what is that? 100 milliohms? Working board? 100 milliohms. Between a red and black line look like a crack. Yeah, it kind of does. Good board. It's probably fine. Well, if I was better at checking MOSFETs, I could tell you for sure. But like, okay. MOSFETs have 3 legs: gate, the source, and the drain. The source and the drain, right? The source is the voltage coming in. The drain is going to be the voltage going out. But the gate is what allows the MOSFET to trigger which direction the electricity needs to flow. Excuse me. So here, and I can look this up to figure exactly out which one is what. I'm assuming, though, gate, source, and drain. These 2 legs are source and drain, should have continuity one way, or should have a diode reading one way, but not the other way. So this is our outer leg of the PCB, right? This is the heatsink. This is the outer leg of the PCB. So these 2 right here should have a diode reading in one direction, right? But not in the other direction. So this is open, and this, come on. .468, so roughly almost 0.5 of a voltage drop. We should get nothing this way. I think the MOSFET's fine. And the gate is 0.7. .5. Why did we get a 0.7 a second ago? 0.7. And I can't check this one because, oh, actually, yes, I can. .4. Come on. And open. Right? Open. And 0.4. Open. And 0.4. So I think that MOSFET at least is fine. Correct me if I'm wrong, please. Please, somebody correct me if I'm wrong. Hmm. Crap, it's 2 o'clock, guys. God dang, I got nowhere with this. We went backwards, guys. We went absolutely backwards on this. What else could blow a fuse? I mean, just... Stroke fixer. Check the Q1, Q41 chip in ohms. Q41. Q31. Q73. Where was Q41? Feel like we'd seen that somewhere. Where was it? There it is, Q41. All fuses and fusible resistors are fine. Yeah, I think so. Okay, so Q41's right here next to these optocouplers. The resistible fuse right here in resistance mode. 0.26 ohms. I should zero this out so that way we get a better reading. .16. On the good board, 0.15. So the fusible resistor here is fine. This resistor seems to be fine, and then the fuse itself is fine. I am not smart enough for this, guys. As much
Gustavo
fun as
Ramonda,
this
thanks
is,
for the sub.
I just don't know what to look at. Okay, Q41. Diode. Which one of these was ground? Well, it's not. There's no ground. This leg. Open. This leg. It's open. Point 0.6. Knowledge gain not lost. Thank you, 8-bit. All fuses, fusible resistors. Yep. FETs are bad. We'll test short across pins. FETs that are bad will test short across pins in either pins 000. Is either pin 0000. Take the chip back off. Replace your fuse to see if the problem persists. Yeah. That would probably be the best way to approach this. I guess reinstall old chip, check if it works like before with the new fuse in the transformer. Would there not be any magic smoke? Maybe the fuse just ready to go. Well, the fuse is toast. The fuse is done. Like, this came out of the Variac. The fuse is done. I'm gonna have to get a new one. Gotta go. Thanks for the stream. Really enjoyed it. Thank you, JFix. I appreciate it, man. I'm about to ready. I gotta get out of here soon myself, honestly. Starting to think that the fuse just went on the Variac system. I've had fuses with transformers just go pop. Okay. Gotta go watch Zach now. Bye, Russ. Oh, is Zach streaming? Maybe we can actually rate him this time. I actually have a second one of these variable transformers, so I could pull the fuse from that. Just as a, I'm not going to power the board with it, but just as a backup fuse, I can pull the fuse from this one, power it on, and see if the transformer alone by itself blows the fuse. But that's got to be it, guys, because kids are going to be coming home soon. They're going to be hungry for lunch. Nothing's powered in, nothing's plugged in, right? So this is just going to be a power on test for the fuse. And it holds. It holds. It stays on. I can get these fuses no problem. This is a 5 amp fuse rated for 250 volts. Do we dare plug it in and blow another fuse for science? She blew hard. Good stream. I'm out too. Later, dress chat. Later, GT Auto. These PSUs pull a lot, but only loaded. Yeah. Zach says he's sorry for what? For science. Do it. All right, let's just do it, and then we'll get out of here. Cause like I said, my kids are gonna be home soon. We have the capability of doing it. So if we know if this pops the fuse, it's something on the board. And as much as I don't want to come back to this next week, guys, I really don't want to come back to this. We'll see. We'll see if I come back to it. Separate my probes so that, we know that they're not touching. Oh, God. I really don't want to come back to this next week, guys. Ground side here. Positive side here. Checking for 12 volts on this side. But I feel like I've learned quite a bit. Turning it on with just the lead plugged in. Power's holding. Switching the meter to voltage. You can see we got 3 volts on the caps. I'm going to plug it in. And we're going to switch it on. If this blows my electrics, guys, it was good stream. I really appreciate you guys hanging out. So thank you for all the donations, all the gifted memberships,
Rusty Russ
everything.
is the best. Woo, woo,
I wonder.
Rusty
let me
Russ.
let's set this up real quick. Let me set this up real quick. I will do some more research. I will watch some more videos. I will try to come back with a second week of better knowledge on understanding power supplies. I might even try to buy a better 15-pin chip from a reputable source. Let's go here. Let's go. Come on, hurry up. Here and here. Did the customization. We're gonna add a redirect and see who's live. LD Tech Pro. Pigeon Milk's coming up. Roy, why the hell do you have so many? Roy, why do you have so many set up, dude? So the only one that's live right now is LD Tech Pro. Is Nano not live right now or what? Or am I just not, is he just not enabled it again? No, he's live. I got a notification. Nano hates me. He genuinely hates me. He doesn't want any of us to go over there. Let me see. Let me see. Just type it in. Nano. Oh, there he is. Okay, wait. I'm sorry, Nano. I'm sorry. I'm sorry. We'll redirect to Nano. If the power goes, it was fun. It was fun, guys. I will see you guys all over there.
Pussy fart jar tip $1. Zach.
Thank you for that. Thank you, guys. Okay, here we go. We good? Can everybody see? Everybody's happy? Here we go. Meters. Yep, here we go. Stand by. It's gonna pop. It was a bad fuse. Okay, I'm gonna see if it goes on. It heard some clicks, so it's probably already on, but clicking it and it's off. So let's turn this off. Turn it back on. And we'll give it a click. We get up to 160 before it drops back down. Yeah, there's still issues going on. But at least we know the fuse was just old. One more time. Do we get 12 volts? We do very briefly get 12 volts. Yep. Okay. That's it. I will try to do some more video research and figure out more about these MOSFETs, more about reading schematics, and I'll go through, watch the video, read the chats, and see what the suggestions are again. PFC dead chip, maybe. Hold down the button. Well, it's a click button, so like it's on, it's off. But okay, we'll do it. Power on, goes up to 360, and then shuts off. Holding it. That should be off. Turning it off, turning it back on, and I'll hold it this time. We'll see if it comes on when we see 12 volts here. Ready? Holding it, and drops back down. Yep. It's fooked. All right. Appreciate you guys. Thanks for hanging out. We'll see you guys all over at Nanos. I'm out of here. I'm hungry. I will see you guys. Thank you all for hanging out. Toltec, Ben, Forder Fix, Grass Puddle, Ace, Simon, Andy, ET, TK. Hey, what's up, TK? Carthor, someone. Hell yeah. Rick, Dan, Stroker Fix, Forder Fix. Who else am I missing? Hot Cows, Rob. Quaggle. Oh yeah, that reminds me. Okay, I gotta go. I do gotta go. But this was the last stream for the donations, and I want to show you guys exactly where we're at, so that way Dan knows as well. We are at a total. Come on.
Rusty Russ Repairs is the best.
No, just freaking log me in.
Who is the best? Rusty Russ is the best.
Come on, log it in. Here we go. Where we at? $339.69 raised by you guys, going straight to Dan's mother-in-law to help with medical bills. You guys are amazing. Thank you so much. I'm out of here. Peace. Where's that?
Rusty Russ is the best.
Rusty Russ is the best.
Rusty Russ Repairs is the best.
Rusty Russ is the best.
Rusty Russ is the best. Whoop, whoop, whoop. Rusty Russ. Rusty Russ.
Rusty Russ is the best. You're 100% correct.
Rusty Russ is the best. Rusty Russ is the best. The best a man can get.
Rusty is the best.
Rusty Russ is the best. Yep. Rusty Russ is the best. That's true.
Rusty Russ is definitely the best.
Rusty Russ is the best, yeah.
Rusty Russ is the best.
No, Rusty Russ is the best.
Who is the best? Rusty Russ is the best.
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 Rusty Russ is the best. The best!
Oh, Rusty Russ is the best. Yeah, his live streams are also very great.
Rusty Russ is the best. Just saying.
Rusty Russ is the best. Rusty Russ.
Rusty Russ is the best. Hello, hello.
Rusty Russ is the best.
Rusty Russ is the best.
Rusty Russ is the best.
Rusty Russ is the best. That's for sure.
Rusty Russ is the best.
Rusty Russ is the best.
Oh, hot, 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 hot! Hot, 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 hot!
Ah!